Good morning, students. Okay, this is from Resonance Junior College. Okay, we have introduced that is what online course, that is concept building course. Okay, this is connecting between your 10th class board and intermediate board. Okay, uh, some of the students or most of the students are there in CBSE board and ICSE board. Okay, so we are switching from CBSE board to and CBSE and ICSE board to uh, that is intermediate board, that is called local board. Okay, because in your CBSE and ICSE you have chemistry, it is what KLMN shell is there, but here in your intermediate board we have introduced that is what first shell, second shell, third shell and fourth shell. Okay, and this is using for what smoothly switching your from 10th class to that is what your board level examinations or JEE mains and JEE advanced examinations. Okay, so you can utilize this opportunity and listen all the classes. Okay, this program is up to 27th May. Okay, so you have listen carefully and this one. See here, this is a chemistry. Okay, this is a basic terms in chemistry. Okay, this is a concept building course. Now, first, what means matter? First, what means matter? Matter may be a solid, liquid, or gas, or like plasma, or fifth state of matter is called Bohr-Einstein state. Bohr-Einstein state. Okay, mainly these three are important: solid, liquid, gas. Okay, matter may be solid, liquid, or gas. Matter mainly classified. Matter mainly classified. That is physical states, and here chemical composition. Physical state again classified to that is what solid, liquid, gas. Solid, liquid, and gas. And chemical composition is again classified to that is mixtures and pure substances. Mixtures and pure substances. And next, mixtures are again classified to homogeneous and heterogeneous. Homogeneous and heterogeneous. And pure substance again classified to elements and compounds. Elements and compounds. On this one. Here matter mainly classified, that is what? That is a physical state and a chemical composition. Physical states are in matter, that is what may be solid or liquid or gas or plasma or Bohr-Einstein state. But mainly we are 90% we can consider that solid, liquid and gas. And in chemical composition, that is what? Again classified to mixtures and pure substances. Here mixtures are two types: homogeneous mixture and heterogeneous mixture. And pure states means what? Elements and compounds. First, what is the difference between this one? Matter, solid, liquid, gas. You know that solid and I can take gas and here liquid. Solid means discipline arrangement. Solid means discipline arrangement. And gas means indiscipline arrangement. Indiscipline arrangement. Okay. Liquid is in between. Liquid is in between. Now, how to convert solid to liquid, liquid to gas? Solid to liquid and liquid to gas. Okay. They have interconversion is there. That is what? Solid to liquid. Solid to liquid is called melting. Solid to liquid is called melting. And liquid to solid. And another one is what? Solid to liquid. Next, liquid to gas. Liquid to gas. That is called vaporization. vaporization. And next, gas to solid, gas to solid, and solid to gas. Here solid to liquid is called melting, and liquid to solid is called solidification or freezing. It is called freezing, or it is also called solidification. And next, liquid to gas, that is called vaporization. Reverse is called that is condensation. That is gas to liquid is called condensation. And here gas to solid is called deposition. This is called deposition. And solid to gas is called, that is called sublimation. That's all. This one, once again. Here solid to liquid, that is called what? Melting. Solid to liquid is called melting. And liquid to gas, that is called evaporization or vaporization. And next, here, but one is there. Generally solid converted to liquid and liquid to converted to gas, but there is a jackpot. Solid is directly converted to gas, that is called sublimation. And gas to solid, that is called reverse process, is called deposition. And here solid to liquid is called melting, and liquid to solid is called freezing, or it is also called solidification, freezing. And liquid to gas is called vaporization, and gas to liquid is called condensation. That's all. Here, how the physical state is interconversion, it is depends on two factors. Okay, one is called temperature, and the second one is called intermolecular forces. These two factors decides the matter may be solid or liquid or gas. Okay, if you can give more temperature, generally that is what physical state existed about. Okay, if it is either some temperature, solid is converted to liquid, and liquid is converted to, if you can provide more temperature, then liquid is also converted to gas. So here temperature decides one of the factor to decide the matter is existed as solid or liquid or gas. And next is intermolecular forces. This is most important. For example, according to this diagram, see this one, according to this diagram. Okay, in the solid, atoms are just touched to each other. Okay, not overlap each other, just touch to each other. Okay, then I can call this is a solid. And in the liquids, atoms are maintain some medium distance. And in the gas, atoms are maintain very far distance. In the solid, why the atoms are close to each other? Because the one factor is what? Another factor, intermolecular forces. In solid, intermolecular forces are strong. Intermolecular forces are strong. And in gas, intermolecular forces are weak. Okay, in between, that is what there, liquid is there. Or simply, solid means so disciplined arrangement, gas means so indisciplined arrangement. Okay, whenever it is a disciplined arrangement, it occupies less space. Whenever it is like indisciplined arrangement, it occupies what? More space. For example, in the universe, okay, that is what, due to global warming, okay, the mainly affected is what? Temperatures are increases. Once the temperatures are increases, thus the water solid or water ice is converted to water liquid. So this can occupies what? More space. This can, water liquid occupies more space compared to water ice is what? Occupies less space. That's why the global warming, the mainly affected is what? This one, water ice. That is cold areas like Arctic areas and Antarctic areas, okay? And in Himalayas, glaciers are, generally glaciers are what? In the form of water ice, okay? Once the temperature increases, the ice is converted to water. So it, but in the universe, space is constant. In the universe, space is constant. Once the water space is increases, means land space automatically decreases. Already we are affected more population, okay? One of the crisis is what? Population. That's why water ice is what? The reason is what? This one. Solid, due to intermolecular forces, the atoms are very close to each other. But in the liquid, the atoms are what? Maintain some medium distance. Maintains some medium distance. That's why two factors are decides. One is a temperature. For example, if the temperature is more, okay, that is physical state exists as what? Gas. If the temperature is low, that physical state exists as what? Solid. And same like if the intermolecular forces are very strong, then it is called what? Solid. If the intermolecular forces are very weak, then it is called what? Gas. That is called a gas. Okay, and this is the interconversion map. Okay, that is what? Solid to liquid and liquid to gas. Okay, solid to liquid you can call melting. Melting, what means melting point means what? At that point, okay, at that temperature, okay, the solid is converted to liquid. At that temperature, solid is converted to liquid. That is called a melting point. And what means boiling point means what? At that temperature or at that point, the liquid is converted to gas. That is called a boiling point. Okay. And another one, this is the interconversion map. Solid to liquid is called melting, and liquid to solid is called freezing. It is also called freezing, also called solidification. Freezing also called solidification. And next is liquid is converted to gas. Liquid is converted to gas. That is called vaporization. And generally rain cycle, that is what? Gas is converted to what? Gas means what? Water vapor is converted to what? Liquid. That is called condensation. And solid, generally solid via liquid, it is converted to gas. But here solid is directly converted to gas. That process is called important sublimation. That process is called sublimation. And reverse process is called gas to converted to solid. That is called deposition. Simply the example is what? Snow. Okay, in the snow, in the atmosphere, what is there? Water vapor is there. But the water vapor, okay, in rains, the water vapor is converted to liquid. That is called what? Droplets, water droplets. That is called condensation. But sometimes water vapor is directly converted to what? Snow. That is called deposition. That is called deposition. Okay. This is interconversion of physical states of matter. This is the interconversion of physical states of matter. Now, next is matter due to chemical composition. That is what? Mixtures and pure substances. First, what means mixtures? Mixtures, two types. Mixtures, two types. That is homogeneous mixture and heterogeneous mixture. Okay. Before you want to understand the topic, first what means solution? That is most important. Solution. Solution contains two ingredients, that is called solute and solvent. Solute and solvent. How to identify solute and solvent? Okay, if it is less amount is there, less amount or less matter is there, then that is called solute. And solvent means more amount. Solvent means more amount. Example, I can call sugar solution. I can call sugar solution. Okay. How to prepare sugar solution? For example, you can take the what? 1 liter of, this is 1 liter of water, 1 liter of water, and you can add what? Okay, some amount of what? NaCl. For example, 10 grams of NaCl is added. Okay. Then here NaCl is called solute and water is called solvent. Water is called solvent. And this is the most important point. Solution must be a homogeneous. Solution must be a homogeneous. What means homogeneous means what? After you can mixing salt with water, okay, if it is distinguishable solute particles and solvent particles, that is called heterogeneous. If it is indistinguishable, means after adding the salt to the water, okay, you can't identify the solute particles and solvent particles, means it is a uniform solution. It is a uniform solution. Then that type of solution is called a homogeneous solution. Then that type of solution is called a homogeneous solution. Okay. For example, sand water. For example, sand water. Here, sand water. How it is? It takes place. Sand water. Same. Take the 1 liter of water. 1 liter of water. And now you can add what? Sand. Now you can add some sand, okay? For example, you can add some 10 grams of sand is there. But after you can mixing sand to the water, but you can easily, clearly distinguishable sand particles and water particles, okay? Then that type of solution is called heterogeneous solution. Solution must be homogeneous. This is most important. Solution must be a homogeneous environment. Homogeneous environment means we can indistinguishable with between solute and solvent particle. But in heterogeneous solution, that is sand water, after you can mixing with heavy, after you can manually studying also, we can easily identify the sand particles and water particles. Means we can easily identify the solute particles and solvent particles. If you can identify solute from the solvent, then that is called heterogeneous solution. If you can't identify from solute from solvent, then that is called what? Homogeneous. Solution must be a homogeneous environment. Solution must be a homogeneous environment. And another one, for example, if you can, same, I can take the 1 liter of water, okay. Now you can add, for example, salt, okay, 10 grams of salt, and another one 10 grams of sugar, okay. 10 grams of sugar. This one also called solution. This one also called solution. It is also called a mixture. Mixture means here, now I can, from the parent is called mixture. Mixture means what? More than one component is called what? Mixture. More than one component is called a mixture. For example, this is a 1 liter of water. This is not called mixture because it is only pure water. It is only pure water. Okay. Now I can add the another component, that is what? Salt. Then you can call what? Mixture. Then you can call the mixture. There is a difference between mixture and pure substances. Mixture means what? Mixture means more than one component is called a mixture. But mixtures are two types, okay? Homogeneous and heterogeneous, okay? The popular word solution refers to only homogeneous, because in homogeneous environment, we can't, we are we are not identified the solute particles from the solvent particles. That type of uniform solution is called homogeneous environment or homogeneous mixture. If it is identified, then that is called what? Heterogeneous. This is not called solution. It is called mixture. Heterogeneous environment is simply is called mixture only. But homogeneous mixture is also called what? Solution. Homogeneous mixture is also called solution. Okay. This one here, for example, I can add the 1 liter of water with 10 grams of salt and 10 grams of sugar. Okay, then it is also called mixture, and it is also called homogeneous solution, because here salt and sugar completely dissolved in 1 liter of water. Means once it is dissolved in water, it is a uniform solution. It is a uniform environment. Then that type of component is called, that is called mixture. It is also called solution. It is a mixture. It is also called as a solution because it is a homogeneous mixture. Homogeneous mixture, another name is called solution. Solution. Okay. And what means binary solution? Binary solution. In binary solution, it is a two-component system. Binary solution means a two-component system. Two-component system. That means one solute and one solvent only. One solute and one solvent only. This is called a binary solution. And what means solution means? Solution is more than two components. More than two components. More than two components. Okay, means here one solvent and more than one solute. This is called a solution. For example, binary solution, for example, water, and you can add what? Salt. Then I can call what? Binary solution. Because in a binary solution, only two components are there. That is what? Water is there and salt is there. Here water is called, if it is excess amount is there, generally water is called what? Suitable solvent. Water is called a solvent. Okay. And sodium chloride is called a solute. One solute and one solvent is there, then that type of solution is called a binary solution. For example, this one is, here this is a solution, okay. Same, I can take 1 liter of water, okay. Now you can add salt and sugar, okay. Then this one I can call what? Solution. This is not called binary solution. This is called a solution only. Or you can add glucose also. You can add glucose also, okay. That is C6H12O6. Still it is also called a solution. But you must be important, after stirring, after mixing, okay, the solute particles are not identified with solvent particles, okay, then only it is called a solution. Or simply after mixing, the solute particles are indistinguishable means not identified from the solvent particles, then only it is called a solution. Otherwise it is called a mixture. Because mixture is two types, heterogeneous and homogeneous. Homogeneous mixture only called a solution. Homogeneous mixture is only called a solution. Okay. Next, this is a mixture is completed. Next, pure substances. Okay, what means the difference between pure substances? That is elements as well as compounds. Pure substances. Substances again classified to elements as well as compounds. For example, here elements you can take the, for example, hydrogen and nitrogen, oxygen, or helium, neon, argon. Compounds, for example, here carbon dioxide, methane, like that one, etc. Okay, or HCl, like this one. These are called compounds. Yes. In elements, okay, pure substances. In hydrogen, it is only hydrogen atoms are there. Okay, in nitrogen, that is what in the nature, hydrogen is existed as H2. Hydrogen is existed as H2. Nitrogen is existed as N2. It is also called dihydrogen. It is also called dinitrogen. Next, oxygen is existed as O2. It is also called, you can call oxygen, or strictly speaking it is called dioxygen. In the phosphorus, it is existed as P4. Tetraatomic state, these are diatomic state. And if the sulfur is existed as S8, that is octaatomic state. Okay, for example, here chlorine is there, it existed as what? Cl2. Fluorine existed as what? F2, like this one. Okay, all are what? Pure. Here, and here see the difference. Elements refers to atoms and molecules. Because helium, that is what noble gases, they are existed what? Only atoms only. Helium existed as helium only. Neon existed as also neon only. Argon also existed as argon only. Okay, there is no molecular state because it is a stable. Okay, later we can tell about why the atoms form molecules. That is in chemical bond chapter. Okay, so these gases are existed as atomic state only, but these gases are what? Like hydrogen, nitrogen, oxygen, like chlorine, fluorine, they are existed as what? Diatomic state. And phosphorus is what? It is a solid, that is what existed as a P4 state. Sulfur is existed as a S8 state. So elements refers to atoms and molecules, but compounds refers to molecules only. Molecules only. That is the difference between elements and compounds. Here compounds, for example, in methane gas. In methane gas, only methane molecules are there. That is a pure. That is a pure. There is no mixing. For example, in HCl gas, only HCl molecules are there. Only HCl molecules are there. And same like, for example, you can take the carbon dioxide gas. In the carbon dioxide gas, only that is what? Only that is the carbon dioxide molecules are there. But in the atmosphere, it is called what? Mixture of gases. In the atmosphere, it is called what? Mixture of gases. It is not pure because majority is how much what? 70, approximately that is what? 71% is what? Nitrogen is there. And 21% is what? Oxygen is there. And remaining that are what? Noble gases. Remaining are what? Noble gases. This is called mixture. This is called a mixture. It is not pure. But these are what? Pure. Pure substances are again classified to elements. Elements refers to atoms and molecules. Here why I can call atoms? Because helium existed as helium only, atom only, helium atom only. Neon existed as what? Neon atom only. Okay. And compounds, that, and also elements refers to what? Molecules. Molecules, that is what? H2, N2, O2. And what is the difference between molecule means what? More than one atom is called a molecule. More than one atom is called a molecule. Okay. Hydrogen is called atom, but H2 is called what? Molecule. H2 is called a molecule. Simply molecule refers to more than one atom is called a molecule. Now what is another one? That is what? Molecule. How to identify? More than one atom is called. More than one atom is called molecule. Is called a molecule. Okay. Carbon dioxide also molecule, because how many atoms are there? More than one atom is there. Triatomic molecule. Carbon dioxide is also called triatomic molecule. And methane is called what? How many atoms are there? Four hydrogens and carbon. That is what? 5 atoms are there. Okay. HCl is also called what? Molecule, because more than one atom is there. That's why it is called a molecule. Oh, that's all. That is a classification of matter. Matter is divided to two types. That is what? Physical states. And next is what? Chemical compounds. Okay. Physical states, that is what? Matter, solid, liquid, gas. And another one is what? Plasma and Bohr-Einstein state. Okay. 5 states of matter is there. Okay. Still till now. But among the 5, 3 is more important. That is solid, liquid, and gas. Okay. And that is the interconversion of solid to liquid and liquid to gas and gas to solid and gas to liquid and gas to liquid to solid. Okay, that one. And next is chemical composition. Chemical composition is again classified to 2 types. That is what? Mixtures and pure substances. Mixtures and pure substances. Mixtures again classified to 2 types. That is what? Homogeneous mixture and heterogeneous mixture. After mixing that, for example, 2 components, okay, if you are distinguishable, then it is called a heterogeneous mixture or simply called mixture. But if it is indistinguishable, then it is also called a homogeneous mixture, and then it is also called solution. Then it is also called a solution. Okay. This thoughts. Sorry, is it, sorry, excuse me, sir. Any questions means, any open the mic for students? No? Okay. Okay, next I can introduce, that is what? Properties of fundamental particles. Properties of fundamental particles. That is here. Particles. Electron, proton, neutron, next here symbol, and here charge And next is relative charge. And next is mass in kgs. And next is relative mass. Relative mass. That is AMU. That is atomic mass unit. Atomic mass unit. Now, electron symbol is what? E minus 1, 0. And proton symbol 1, 1. And neutron symbol, that is 0, 1. And charge minus 1.602 into 10 power minus 19 coulombs, charge in coulombs. Coulomb. And proton charge is plus 1.602 into 10 power minus 19 coulombs. And neutron charge is 0. And relative charge, that is what, minus 1, here plus 1, here 0. And mass 9.1 into 10 power minus 31 kgs. And here 1.67 into 10 power minus 27. And here same, here also same mass, 1.67 into 10 power minus 27. But it's slightly higher the mass, that is a neutron. Strictly speaking, this is 1.6748 into 10 power minus 27, and this is 1.6725 into 10 power minus 27. And the relative mass, this was 0.00054, and this one 1.00727, this one 1.00867. This is the fundamental particles. Okay, earlier first Dalton discovered the atom. Dalton discovered the atom. Atom is what? Indivisible particle. According to the Dalton, atom is an indivisible particle. Okay, but after the Dalton, okay, atom also divisible. Atom also consists of what? Fundamental particles. Main fundamental particles are what? Electron, proton, and neutron. Electron, proton, and neutron. Each atom must be generally atom is what? Spherical shape. Each atom must be consist of nucleus. Each atom must be consist of nucleus. And the electron is revolving around the nucleus. Electron is revolving around the nucleus. And the nucleus, this is a nucleus. This nucleus contains what? Protons and neutrons. Protons and neutrons. Here protons is a charged particle, that is a positively charged, and neutrons, there is no charge. There is no charge. So in the nucleus, the protons and neutrons commonly called nucleus. Nucleus. Okay. Each atom must be consist what? One nucleus is there. Okay. That is in the center of the pot. Okay. That charge is what? Positive, because proton contributes the positive charge. Neutron doesn't contribute the charge. That's why here proton dominates in the nucleus. And electron is what? According to Bohr model, electron is revolving around the nucleus because of some force of attraction or Coulombic force of attraction, because electron is negatively charged and nucleus is positively charged. That is naturally attraction is there. That is there. Okay. Till now, that is what atom is until Dalton is discovered. Until Dalton discovered the atom, atom is undivisible or indivisible particle. Okay, this uncuttable particle. But atom also contains what? Atom also cuttable, because atom also consists what? Fundamental particles are there. That is electron, proton, neutron, positron, etc. But mainly fundamental particles are this one: electron, proton, and neutron. Electron, it is a negatively charged particle. This is indicates what? Charge. And this one indicates mass. 0 indicates mass. Here, proton, the charge is a positive charge, +1. Okay, you can call +1. And mass is what? 1. Mass is approximately 1. And neutron, the charge is 0 here, and the mass is 1. And strictly speaking, you want to calculate the charge. That is what? In coulombs, that is electron charge and proton charge is same. Only magnitude is that is what sign is different. Magnitude is the same. Magnitude is the same. Only sign is different. Electron charge is negative charge and proton charge is a positive charge. Neutron there is no charge. And relative charge, that is what -1, and here what +1. If you can take 1 here +1. If for example here you can take -2, here you can must be take the +2. That is called relative charge. And mass of the electron is 9.1 into 10 power -31 kg. Okay, that is a very, very negligible mass. And which one is here? Proton mass and neutron mass are similar. But slightly advantage is what? Neutron mass is heavier than the proton mass according to the mathematical values. Here 1.6725 into 10 power -27, but here 1.6748. That's why neutron is a slight edge than proton in terms of mass, but approximately these mass are equal. That is a proton mass and neutron mass are equal. And relative mass. How to calculate relative mass means what? We are comparison with here electron mass with proton mass or electron mass with neutron. For example, electron mass is what? 9.1 into 10 power -31, and you can divide by what? 1.67 into 10 power -27. Then the value is 0.00054 is obtained. Okay, that is called relative mass, or it is also called here electron mass. Electron mass equal to 1 by 1840 times of mass of proton. Okay, or another way mass of proton or neutron. Mass of proton or neutron is how many times of electron? Means 1840 times of mass of electron. 1840 times of mass of electron. That's why in the atom, okay, we can't consider electron mass, because here is how many times? 1840 times of mass of proton mass is 1840 times of mass of electron. That's why in atomic mass, because atom contains electron, proton and neutron. Electron, proton and neutron. So atomic mass contributes what? Generally mass of proton plus mass of electron and mass of neutron. But due to electron mass is very negligible, the reason is what? Electron mass is very, very small. So is one mass of proton or mass of neutron. How many times of mass of electron? 1840 times of mass of electron. That's why in the atom, electron mass is negligible. That's why we can't consider the mass of electron. That is what? Mass of proton plus mass of neutron only. So that's why atomic mass, okay, equal to mass of proton plus mass of neutron only. So we can't consider the electron mass. The reason is what? It is mass of proton is how many times of mass of electron? 1840 times of mass of electron. Or in another way, mass of electron is called what? How many times of mass of proton? 1 by 1840 times of mass of proton. That's why we can't consider the electron mass. Means we can neglect in the atom, we can neglect the mass of electron. So atomic mass contributes only mass of proton and mass of neutron only. In general, you know that an atom contains what? In the nucleus, each atom must be contains one nucleus is there. In the nucleus, protons are there and neutrons are there. In the nucleus, protons and neutrons are there. And proton is contributes the positive charge and neutron can't contribute the charge. And another one is what? Electron. Electron is revolving around the nucleus according to Rutherford and Bohr's model. Okay, so atom contains three fundamental particles, mainly three fundamental particles, that is electron, proton and neutron. So initially the three particles must be contribute the atomic mass, but Okay, but mass of electron is very negligible value compared to mass of proton and mass of neutron. That's why atomic mass contributes only for what? Mass of proton and mass of neutron only. Mass of proton and mass of neutron only. Okay, and what is the role of neutron in the nucleus? Because that is what to increase the stability of atom, to increase the stability of atom. Because proton charge is what? Positive charge, and another proton also positive charge is there. Due to positive repulsion is takes place. That's why we can place what? Neutron is there. So the neutron is the neutron protects the, that is what, neutron protects the repulsive forces between two protons. That's why neutron also crucial, even though it doesn't contribute the charge. That's why neutrons increases the what? Stability of the atom. That is called N by P ratio. That is called N by P ratio in nuclear chemistry. Okay, next. I can introduce atomic number. Atomic number. That symbol is called Z. Here I can reverse X. Here in the bottom I can write Z, and in the top I can write A. Here X refers to any element in the periodic table. X refers to any element in the periodic table. This is most. And Z refers to atomic number of the elements. Atomic number of the elements. Atomic number of the element. And A refers to atomic mass of the elements. Atomic mass of the elements. That's all. This is the notation of the symbol. Okay, X, Z, A. Here X refers to any element in the periodic table, and Z refers to what? Atomic number of the element, and A refers to what? Atomic mass of the elements. Next. This is most important. Atomic number equal to notes. Atomic number equal to number of protons. Atomic number equal to number of protons. And next is note 1 and note 2. Atomic number may be equal to number of proton, number of electrons, may be equal to number of electrons, or may not be equal to number of electrons. Number of electrons. This one. Once again, this is most important. Okay. Atomic number equal to number of protons. Atomic number equal to number of protons. And second note is atomic number equal to number of electrons, may be equal to number of electrons or may not be equal to number of electrons. Okay. Why? Here you can remember proton means permanent. Proton means permanent. And proton also refers to what? Powerful. Proton also refers to powerful. Now, for example, I want to calculate the hydrogen. Hydrogen contains how many protons, how many neutrons, and how many electrons. What is the hydrogen atomic number? Hydrogen atomic number is 1. Okay. So once the atomic number 1 means what? Here atomic number refers to what? Z letter. Z equal to 1. So how many protons here? Protons is protons also what? 1 proton. And electron. How many electrons are there? 1 electron. And neutron. Okay. This is a symbol hydrogen 1 1. Okay. Remember hydrogen atomic number 1 and atomic mass also 1. Atomic mass is experimentally determined. Chemistry means experimental. That's why atomic mass determined experimentally. Okay. And we want to calculate the neutrons. The formula is A minus Z. Here A refers to atomic mass. And Z refers to atomic number. atomic number. That's why how many neutrons are there? Atomic mass of hydrogen is what? 1, and atomic number of hydrogen is what? 1. That is what? 0. So neutrons is 0. Neutrons is 0. Next, I can take hydrogen. Okay, it is exists like this one, hydrogen and H plus and H minus. Okay, this is a neutral. Okay, neutral. And ions, in chemistry, ions are two types. One is called cations and another one is called anions. Cations refers to positively charged particles. Anions refers to negatively charged particles. In chemistry, atoms as well as ions as well as molecules are there. Okay, in ions, two types of ions, that is called cations and another one is called anions. Cations refers to positively charged particle, anions refers to negatively charged particle. And the most important another thing is what? Chemistry is quite opposite to mass. Okay, in mass, you know that plus means what? Addition, minus means subtraction. But in chemistry, plus means what? Subtraction, minus means addition. Okay, here this is the atom. Okay, this contains what? How many protons? 1 proton, because atomic number of hydrogen is what? 1. And how many electrons? Because it is 1 electron. Okay, and how many neutrons means what? 0 neutrons. And H plus also atomic number is 1 only. Don't change the atomic number. If you can change the atomic number means what? Element also changes. Okay, and atomic number always equal to what? Atomic number always, it is always equal to number of protons, always. Okay, that's why here hydrogen has H plus also has 1 proton. But how many electrons here? So here already given atomic number may be equal to number of electrons or may not be equal to number of electrons. That's why here H plus is there. That's why here what? Initially it is 1 electron is there, but here positive charge is there. Positive means what? We can subtract the 1 electron. Okay, that means what? 1 minus 1, that is called what? 0 electrons. 0 electrons. And neutrons similarly, that is what? 0 neutrons. Because that is neutrons formula is what? There is no electrons here there. Atomic mass minus atomic number. H plus also atomic number is 1. Okay, and atomic mass also 1. Atomic mass is not changes. Atomic mass is not changes for ions. Next, H minus. Here also atomic number is what? 1 only. And here how many protons and how many neutrons and how many electrons? Here protons, 1 proton only, because atomic number always equal to what? Number of protons. Next, how many electrons? Initially hydrogen has what? This is the reference. Hydrogen has 1 electron is there. That means what? H minus. Minus means what? We are adding another electron. So 1 plus 1, that is called what? 2 electrons. 2 electrons. And next is what? How many neutrons? Same, that is what? 0 neutrons only. Okay. In chemistry, hydrogen existed as 90% is what? Positive charge. Okay, but in 10% of the cases, so H minus also there. This type of hydrogen is called hydride. This type of hydrogen is called hydride. Okay. Next, I can take oxygen. O minus 2. Okay. What is the oxygen here? O minus 2. Okay, I can take another one is also O plus. Here oxygen atomic number 8 only. Okay. Okay, later I can write the atomic numbers in next class. Oxygen 8. How many protons, how many neutrons and how many electrons? Here atomic number equal to number of protons. That's why 8 protons. And atomic number may also in neutral, because it is a neutral charge. This is what? Negative charge. This is what? Positive charge. Okay. In neutral cases, atomic number equal to number of electron. But in ions cases, atomic number may not be equal to number of electrons. Refer that one. But atomic number blindly you can. Atomic number always equal to number of protons. So 8 protons, here 8 electrons, and okay, later next class I can tell about how to write the atomic numbers and atomic masses here. This is 8, and you can write like element, you can write like symbol. X means what here? Oxygen. Here bottom portion is 8 and top portion is 16. 16 refers to atomic mass and 8 refers to atomic number. So neutrons, what is the formula? A minus Z. A minus Z, atomic mass is what? 16, and atomic number is what? 8. 16 minus 8 is what? 8. That is 8. And O minus also atomic number 8 only. Don't change the atomic number. If you can change the atomic number, element changes. For example, you can write the 9. Then 9 atomic number refers to what? Fluorine atom, not oxygen atom. Okay. So here same, how many protons? That is 8 protons only, because atomic number equal to number of protons. Atomic number equal to number of protons. And here ion is there. This is what? Negative charged ion. Generally negative charge means what? In chemistry you can add the electron. Okay, here O minus means what? Minus 1 electron. Already in neutral atom is what? Oxygen has 8 electrons is there. 8 minus means what? 8 plus 1. That's why it is what? 9 electrons. And that is what is a neutron? Similar. That is A minus Z. That is what? 8 only. And next O minus 2. O minus 2. What is the atomic number of O minus 2? 8 only. So how many protons? Okay, 8 protons. But how many electrons here? 8 minus 2 means what? 8 plus 2. 8 plus 2. That is what? 10 electrons. 10 electrons. And how many neutrons? Similarly same. Neutrons can't changes. And O plus. Here also atomic number of O plus also 8 only. Okay, how many protons here? 8 protons. But here how many electrons are there? 8 plus means what in chemistry? 8 minus 1. That's why 7 electrons only. 7 electrons only. This is a important concept. That is what? Atomic number and atomic mass. Okay, if you know the atomic number, then we can easy to find the what? Number of protons and number of neutrons and number of electrons for the respected atom. But remember, this one is important. Atomic number always equal to atomic number always equal to number of protons. Wise. Okay. Atomic number always equal to number of protons. Atomic number always equal to number of protons, and atomic number may not be equal to number of electrons or may be equal to number of electrons. Okay. This is the concept of atomic number. Next, isospecies. Isospecies. Mainly isospecies are that are classified to isotopes, isobars, isotones. Next is isoelectronic species. Isoelectronic species. In chemistry, species, the species refers to species. This species refers to maybe atom or molecule or ion. In chemistry, species refers to atom or molecule or ion. This species refers to, in English word, that is called what? Refers to living things as well as non-living things. Okay. If you have any confidently clarity is there, that is atom is there, then you can call atom. If you have no clarity, is it atom or molecule or ion, then you can call what? Safe answer, species. Safe answer is a species. Species refers to atom or molecule or ion in chemistry. Species also refers to what? Human beings, animals, living things, and wood material, that is what? Non-living things. Species refers to living things as well as non-living things. Okay, but in chemistry, species refers to maybe atom or molecular ion. Okay, and iso indicates in chemistry same, similar. Iso indicates same or similar. Okay, here isotopes. What means isotopes? Means same atomic number, but different mass number. And isobars. Okay, here which one is same? Same mass number, but different atomic number, Next, isotones means what here? Same number of neutrons. Same number of neutrons. And isoelectronic means what? Same number of electrons. Okay. Here one must be same. Which one is same here? Same atomic number. That's why it is called iso. Here isobars, which one is same? Same mass number. And in isotopes, which one is same? Same number of neutrons. And isoelectronic means what? Same number of electrons. So iso refers to in chemistry is same or similar. Isotopes, same atomic number. Isobar, that means what? Which one is same? Same mass number. Okay, and isotones, same number of neutrons. And isoelectronics means what? That is a same number of electrons. Now first I want to isotopes. Okay, the best example of isotopes, hydrogen. Hydrogen has example. Hydrogen has three isotopes. That is H11, H12 and H13. H11 is called protium. And H12 is called deuterium. And H13 is called tritium. Okay, that's all. Here, same atomic number. See here, this one. Here, always this one. In any element in the periodic table, X, Z, and A. X refers to what? Any element in the periodic table. Z refers to what? Atomic number of the element. And A refers to what? Atomic mass. That's all. This is the notation of the any element in the periodic table. Here, this 1 indicates what? Atomic number. And this 1, 2, 3 indicates what? Atomic mass. Isotopes means what? Same atomic number but different mass number. Same atomic number but different mass number. Okay. And here in the nature, 90% is obtained. That is what? 90% is occurrence. Okay, occurrence is protium is there, and 9% is deuterium is there. And very rare element is that is called what? Very rare isotope is called tritium. That is 0.0005% is there. Tritium is there. Okay. And chlorine also 3 isotopes. Okay, chlorine has 2 isotopes. Chlorine, 2 isotopes. That is chlorine 1735 and chlorine 1737. Chlorine has 2 isotopes. Like carbon also 3 isotopes are there. Carbon, that is C612 and C613 and C614. Which one is stable isotopes means what? Carbon 612. This is a stable isotope. Okay. And C614 is called what? Unstable isotope. And this is used for radioactive dating. Unstable isotope. This is used for radioactive dating. Means you want to find the age of fossils and plants or animals. Okay, dead animals. Okay, then we can use this isotope. That is a carbon 614 isotope. Okay. Next. Sir, is completed? Break. 10:10. Oh, okay. Next is isobars. Here isobars means what? same mass number, but different atomic number, number. Same mass number but different atomic number. Example, argon 18 and 40 and calcium 20, 40. Another example, potassium 19, 40 and calcium 20, 40. That's all. Here same mass number here. This is a mass number is same. Here argon and calcium. Okay, but atomic number is different. Okay, that's why isobars. And another pair is called potassium. That is 1940 and calcium 2040 because here mass number is same. That's why it is called isobars. Isobars. Next is called isotones. Next is called isotones. Isotones means what? Simply same number of neutrons. Same number of neutrons. Same number of neutrons. Examples, silicon 14, 30. Next, phosphorus atomic number 15, 31. Next is sulfur 16, 32. That's all. Here silicon atomic number is 14, phosphorus atomic number is 15 and sulfur atomic number is 16. Okay, same number of neutrons. How to find the neutrons here? Neutrons equal to what formula? A minus Z. A refers to atomic mass. A refers to atomic mass. Z refers to atomic number. Z refers to atomic number. This is the symbol of, once again, X, Z, A. Here Z refers to atomic number, A refers to atomic mass. For example, silicon. Now this one has how many neutrons? That is what? A minus Z, that is what? 30 minus 14. Here also 31 minus 15. And here that is 32 minus 16. How many neutrons? Here 16. Here also 16 neutrons. Here also 16 neutrons. So neutrons are similar. Okay, then that are called isotones. Isotones. Okay, this is the number of neutrons. How to find the number of neutrons? That is atomic mass number minus atomic number, or atomic mass minus atomic number. A refers to atomic mass and Z refers to atomic number. Next, isoelectronic species. Isoelectronic species. Isoelectronic species. Isoelectronic species means what? Simply same number of electrons. Same number of electrons. That is example, O2 minus, F minus, Na plus, Mg plus 2, Al plus 3, neon. This one. For example, oxygen. What is the atomic number of oxygen? That is 8. Atomic number of fluorine is 9. Sodium atomic number is 11. Magnesium atomic number is 12. And aluminium atomic number is 13. And neon atomic number is 10. Out of the 1, 2, 3, 4, 5, 6, among the 6, only one is neutral atom, that is neon. In neutral atom, number of protons and number of electrons are same. Here, how many protons here? Atomic number equal to number of protons. That's why it is called what? Simply you can blindly tell about 10 protons. But in neutral atom, atomic number also equal to what? Number of electrons. That is what? 10 electrons. 10 electrons. And now see this one. ions. You know that in chemistry, ions are two types. That is what? Positive and negative. Cation refers to positive and anion refers to negative. And once again, chemistry is quite opposite to maths. Okay, in maths, generally, plus means what? Addition, and minus means subtraction. But in chemistry, plus means what? Subtraction, minus means addition. Remember that one. Okay, here. So here, how many protons here? Here, how many protons? Atomic number equal to what? Number of protons, always. That's why 8 protons. But how many electrons? 8 minus 2 means what in chemistry? Add 8 plus 2. That is what? 10 electrons. Next, fluorine. Okay, how many protons? 9 protons. But how many electrons? 9 minus 1 means what? 9 plus 1. That is what? 10 electrons. And Na plus, how many protons here? 11. Atomic number 11 means what? Blindly you can tell about 11 protons, but how many electrons? 11 minus 1 means what? 10 electrons. And magnesium, that is what? Atomic number 12 means what? 12 protons, but here plus 2, that means what? Remove the 2 electrons. That means what? 12 minus 2, that is 10 electrons. And same like aluminum plus 3, that is what? Atomic number 13 means what? 13 protons, but here positive charge, how much positive charge is there? Plus 3 is there. That's why 13 minus 3. That is called what? 10 electrons. That's why here electrons are okay. So that's why it is what? 10 electrons, here 10 electrons, here 10 electrons, 10 electrons, 10 electrons, 10 electrons. Okay, that's why isoelectronic species means what? Same number of electrons. That's why it is called what? Isoelectronic series. Okay, and okay, that's what. Okay, once again. Okay, isospecies. Okay, that is mainly classified as isotopes, isobars, isotones, and isoelectronic species. In chemistry, iso refers to same or similar. You know that in lower classes, isomerism. Isomerism means what? Same molecular formula. Isomerism means what? Same molecular formula. At least one must be same. Okay, isomers means what? Same. The compounds having same molecular formula but different properties. But which one is same here? Molecular formula same. The same cases here. Isotopes means what? Which one is same? Atomic number is same. And isobars means what? Same mass number or same mass. And isotones means what? Same number of neutrons. And isoelectronic means what? Same number of electrons. Okay. And which one is differ here? Isotopes means what? Same atomic number but different mass number. And isobars means what? Same mass number but different atomic number. Isotones means what? Same number of neutrons. Isotones means same number of neutrons. Same isoelectronic species means what? Same number of electrons. Okay. This is examples of isotopes. That is what? Hydrogen has 3 isotopes in the, that is what? Protium, deuterium, and tritium. This is how it is isotopes are obtained in the nature means what? Due to abundance. Hydrogen, 100% hydrogen is not only obtained as protium. Okay, it is maybe 80% protium is there. Maybe that is what? 20% deuterium. 10 to 15% deuterium is there. Okay, less than 5% is tritium is there due to abundance nature. Okay, if it is only 100% protium is there means what? Hydrogen there has no isotope, only one element only. Okay, protium is also called okay, protium and deuterium and tritium. Okay, next. Isobars, that is what? Same mass number and different atomic number. Okay, simply by looking the examples you can easily identify. Okay, atomic mass is same. Okay, but the element is what? Once the element changes means what? Atomic number also changes. This one argon refers to what? 18 atomic number. Calcium refers to what? 20 atomic number. But in previous cases atomic number same means what? Element must be same. Okay, same. Isotones, that is what? Same number of neutrons. That's all. That is what? Newton's formula, A minus Z. And same like that is what? Isoelectronic species. That means what? Same number of electrons. Okay, students, thank you for listening. Okay, you have one short break from 10:10 to 10:20. Okay, next class is physics. Physics class is started. Okay, once again, thank you.
can I keep? पॉकेट में डाल दूं. Like this, huh? Good morning, my dear children. Welcoming you on behalf of Resonance. Yeah, I'm Raghavendra, teaching you physics. This is a concept building course. We are starting from the beginning. Don't think that we are teaching you everything. Just when you'll be coming in the month of June, before that, related to physics, some basic fundamentals I'm going to introduce to you people. First, what is physics? This word had come from physica, a Latin word. Aristotle has introduced the word physics. Physica means nature. Means in physics, you are studying about nature. Actually, it is that branch which deals with matter and energy. You know about Lord Venkateswara. In 2 steps, he measured entire universe. Just you think about 2 words, matter and energy. Entire universe you can measure with the help of only 2 words, matter and energy. A child has told me, sir, matter and energy, only 2 words, no. We'll study these 2 words, physics will be over. But if you consider matter and energy, entire universe is hidden behind these 2 words. Now, come towards matter. If I talk about quantity, then you have 2 types of quantity, physical quantity and metaphysical quantity. In physics, we study about only physical quantities. We do not study about metaphysical quantities. Physical quantities are those which can be sensed from our sensual organ and which can be measured. Metaphysical quantities are those quantities which can be only sensed. All kind of feelings are metaphysical quantity. You do not study about any metaphysical quantity in physics except a few. Those metaphysical quantities which are directly dependent on physical quantities, exceptional case like color, pitch, we are studying in physics. In physics, we will study about only physical quantities. If you want to classify physical quantities, again, you will be taking them as a scalar quantity, vector quantity, and tensor quantity. If I am considering a scalar quantity, it will have only magnitude. For example, you take speed, you take distance, only you will have magnitude. You will not have direction. If you talk about a vector quantity, for that you have magnitude as well as direction. But it is not so simple. When you talk about direction, it is not so simple in the sense that for that you will have to consider a frame of reference. Now, so many things are there to know about a frame of reference. For example, I want to talk about displacement of a particle. You will have to consider one origin with 3-dimensional frame of reference. X-axis will be there, Y-axis will be there, Z-axis will be there, and there should be origin. Suppose I have a particle which is moving in a plane. a plane will have only two dimensions. I consider this as x-axis, this as y-axis, and I want to talk about position coordinate of a particle. This position coordinate of a particle, if you take x, y, if you are taking this is origin, you have only two dimensions. First thing, that we are three-dimensional object. We stay in three-dimensional world. We interact with only three-dimensional objects. This is a matter of question that whether universe is three-dimensional or multi-dimensional. When you will grow up, then you will think about that. At this time, we will talk only about three-dimensional space. So first, think about a vector quantity. Now, I want a car is moving on a road towards east with velocity 5 meters per second. Now, when you talk about 5 meters per second, that gives you magnitude. So if I have a vector quantity, it is represented by this. It will have mod, and this is a cap. Mod means it is giving you magnitude of vector quantity, and a cap, unit vector corresponding to vector A, will be giving you direction. As I have told you about 5 meters per second towards east, it means that in this mod A will be 5 meters per second, and A cap is 1 towards east. Okay? So a vector quantity, if you want to represent, you should need a three-dimensional frame of reference having origin, x coordinate, y coordinate, and z coordinate. On the board, I have shown you a two-dimensional frame of reference. So if a particle is moving in a plane, you will be considering only two dimensions, means it will have x coordinate and y coordinate. If I consider a particle moving along a straight line path, it means it is moving only in one dimension, then it will have only one coordinate. How you represent a vector quantity? For representing a vector quantity, you take an arrow. Okay? This is vector A. The mod A, suppose this is AB. The length AB gives magnitude of vector A. And direction of AB will be giving, direction of vector A. You can say that length of the line will be proportional to magnitude of vector A. Clear to you? So a vector quantity can be represented by a single arrow. As magnitude is increasing, length of line also will be going on increasing. In too much detail, I'll be teaching you vectors in the month of June when you'll be coming here. Here, just a basic concept related to all these quantities we are going to give to you. Now, if I have a vector quantity, it must obey rules related to vector. So some basic vectors you should know. Just now, I have used a unit vector, which has magnitude 1, but it has a specific direction. There will be equal vector, negative of a vector, null vector, so many different type of vectors we will have. If you take null vector, it means that if you consider a particle thrown vertically up, at topmost point, what will be its magnitude? It will be 0. What will be direction? Direction cannot be specified. It will be considered as a null vector. If you take negative of a vector, suppose this is vector A, and I want negative of vector A, means magnitude will be equal, but direction will be reversed. So its direction will be like this. This will become negative of vector A. Clear to you? It obeys so many rules. If I want to add vectors, I will be using triangle law, polygon law, parallelogram law. Perhaps you people in class 9th or 10th, you have studied about these laws. If you talk about triangle law for addition of vectors, then I have two vectors, A and B. We want to add these two vectors. Think about a triangle. I'm thinking about a triangle A, B, C. Vector A is represented in magnitude and direction by side AB of the triangle. Vector B is represented by side BC of the triangle. The resultant addition A plus B in magnitude and direction will be given by third side of the triangle taken in the reversed order. Means if you want A plus B, this will be equal to AB plus BC, and this will be equal to AC, and this is your resultant. Converse is also applicable. Okay? In too much detail about all these things, we'll be talking in the month of June when you'll be coming here. At this time, just for concept building, basics of vectors I'm telling you, and not only this, along with this in 1 month, we'll be speaking about kinematics, dynamics, Newton's laws of motion, work power energy. All these chapters in brief we will be giving you fundamental concept so that when you'll come in the month of June, you'll be understanding. Just giving basic concept. For example, we are not going to teach you those kind of problems which will be based on differentiation, integration, maxima, minima, and all. Because for solving those kind of problems, we'll have to teach first mathematics, differential calculus, integral calculus, and all. Some of you who have taken foundation courses, they may be knowing, but most of you may not be knowing. And for IIT preparation, we need even those mathematics, because if you don't know differentiation, even fundamental problems related to kinematics or dynamics, you will not be able to know. Just, I'm showing you some questions. I will just show you some question. Suppose this is national highway. This is a national highway. Okay? And here is one house. Right? I want to reach to that house moving on this national highway. Suppose this house is situated at a distance D. Right now? Now, here you have agricultural field. Right now, you have complete agricultural field. You can move on this road with velocity v. Right? But as you are taking turn in this agricultural field, your velocity decreases by factor eta. Means your velocity becomes v by eta. You want to reach to this house in minimum time. You have one way that you will come from here and you can go like this because your velocity will be more. Other way is there that you will be coming by this way, and from somewhere you will take turn and you will move towards the house. But as you will move in agricultural field, your velocity will decrease. Right? No. Now, I may ask you that at what distance from this junction you should take turn towards the field so that you can reach to the house in minimum time. Now, how will you solve this problem? For solving this kind of problem, you need a concept of maxima and minima. Of these kind of problems, we'll be learning after learning differential and integral calculus. Don't think that math teacher will be teaching you long after, means I think that after 5-6 months they will start differential calculus. So in our physics we have so nicely we have made our schedule that in the beginning when you will be coming, we'll be teaching you mathematical tools. Means that mathematical part which we need for learning physics. We will teach you basics of differential calculus, integral calculus, vectors in too much detail. At this time, I have simply given you definition of vector. I have not taught you vectors. I have just told you what is a vector quantity. A vector quantity is that which has magnitude and direction. To represent a vector quantity, you need a three-dimensional frame of reference. Origin, x-axis, y-axis, z-axis. The position coordinate of a particle, for that you will have three coordinates, x, y, z, in three-dimensional frame of reference. The different type of vectors, in brief, I have told you. Right? Whereas addition of vectors are concerned, there are so many laws, only one law, triangle law I have told you. You will have, if you want magnitude of addition of two vectors, then you need parallelogram law. Perhaps you know, resultant of two vectors A and B acting at an angle theta will be equal to under root A square plus B square plus 2AB cos theta, where A and B represent vector and theta is the angle between vectors A and B. All those things in too much depth we'll be teaching at that time. At this time, for concept building, just basics I have told you so that I can enter into kinematics. Kinematics, this problem whatever I am showing you, for solving this problem at this time we cannot learn. Because for learning this kind of problem, we have to know maxima and minima under calculus. Right? I will show you other problem also, which is important for your IIT. Suppose there is a tree which is situated at a height h from ground. A fruit had fallen. Take jamkai, guava. It is falling from here. If you don't like that, take a ball. It is freely falling. At a certain distance, you have an inclined plane. After hitting this inclined plane, this velocity of this body become horizontal, and finally it had fallen on the ground like this. This is ground. Now this is height h. I will ask you, at what height from the ground this inclined plane would be so that time taken by this body to reach to ground would be minimum. You need again here concept of maxima and minima. That these type of things we are not going to teach you now. Right? So starting motion, our first unit is motion. In that we will be teaching you kinematics and all. For that some more basics related to vector I need. I have told you about position coordinate. Position coordinate means in 3 dimension x, y, z coordinate. In 2 dimension, you will have only 2 coordinate x and y. Right? So if I take triangle law, suppose this is vector A and this is vector B. I am considering like this, and you are using parallelogram law. Complete derivation we will be teaching you at that time. Just basics I say you. If this angle is theta, resultant will be given by this diagonal. If you name it A, B, C, D, okay, then mod of resultant, this will be equal to under root mod A squared plus mod B squared plus 2 mod A mod B cos theta. We need this. Even for learning kinematics, this basic formulae we need from vectors. Okay? Now, come towards motion. Right? You understood no frame of reference. Without considering a frame of reference, we cannot talk about any vector quantity. Now, if I want to talk about rest and motion, topic name is motion. You should know what is rest, what is motion. You have heard about Einstein's special theory of relativity. Everything is relative. Physical quantity you take or metaphysical quantity you take, everything in this world is relative. The rest and motion, they didn't have any absolute meaning. For example, if a person is sitting in a train, your frame of reference is fixed with respect to train. So with respect to co-passenger, a person sitting in train, he will be at rest. But if your frame of reference is fixed with respect to ground, earth, the same person is in motion. So without considering a frame of reference, you cannot talk about rest or motion because both are relative terms. Only rest and motion are not relative. Everything is relative. You are standing on ground. With respect to earth, you are at rest. But someone is moving in a car on the road, and if a frame of reference is fixed with respect to car, then with respect to that person, you are in motion. So here important thing is a frame of reference. Frame of reference is of 2 types. Inertial frame of reference and non-inertial or accelerated frame of reference. If you talk about inertial frame of reference, in that Newton's laws of motion will hold good. A frame of reference which is fixed or which moves with constant velocity with respect to distant star is considered to be inertial frame of reference. But we are small kids. We are not talking about motion related to space. We are not talking about motion of a satellite, motion of a planet, motion of a star. Our all motions are on Earth. So distant star, actually correct definition is with respect to distant star only. And it is IIT asked. A frame of reference is considered to be inertial if you consider a frame which is at rest or which moves with constant velocity with respect to distant star. But at intermediate level, a star will replace from Earth. If a frame of reference is fixed with respect to Earth or which moves with constant velocity with respect to Earth, we consider that frame of reference to be inertial. Understanding, no? In inertial frame of reference, if you consider Newton's laws will hold good. You need to consider only real forces to explain any phenomena which is happening in inertial frame of reference. But you take a frame of reference which is accelerated, which is not at rest, which is not moving with constant velocity with respect to distant star, or now for us with respect to Earth, that frame of reference will be non-inertial or accelerated frame of reference. The simplest example you take, a car is accelerating on the road. You take a giant wheel, it is revolving, rotating. That frame of reference fixed with respect to distant, if you are considering giant wheel, that frame of reference is non-inertial. Right now, to explain any phenomena in non-inertial frame of reference, along with real forces, you need to consider some pseudo force. I will be talking about these pseudo forces in detail when I will be talking about Newton's laws of motion. At this time, I just want to use a concept of inertial frame of reference. A phenomena will not change if you move from one inertial frame to other inertial frame. But a phenomena will be changed if you move from one inertial frame to a non-inertial frame of reference. Example I give you. Suppose I have a lift, right? Open lift. Near construction site you will be seeing. Wherever construction site is there, their open lift will be there, roof will not be there. You are standing in that lift, and let us throw a ball vertically up. Some velocity you take. Let us suppose you are projecting with velocity 10 meters per second. So you have a ball in your hand and you have thrown vertically up with velocity 10 meters per second. You know in class 10th, going air resistance neglect, G constant, acceleration due to gravity you take constant, G value you take 10 meters per second squared. Now, how much time it will take? You are projecting body vertically up from here. Lift is there with velocity 10 meters per second, and this is U. You know that while going up, it will take time U by G, air resistance neglected. Right now? The 10 by 10, 1 second. Now, in return journey, how much time it will take? Again, it will take U by G. Total time of flight, 2U by G. So it will become 2 into 10 by 10. This is 2 seconds. Am I right? You have used formula T equal to 2U by G. Right? 2 seconds. Lift at rest, you are throwing body vertically up. It will come back to your hand again after time 2 seconds. Right? Now suppose lift is going vertically up with velocity 5 meters per second. I have taken half, 5 meters per second. What are you thinking? How much time it will take? Will it take less than 2 seconds to come back to your hand? Is it possible? Or it will take more than 2 seconds? What are you thinking? Because there is no way to interact now with you people. Simply you can listen to me. You'll be surprised to know the answer. Lift at rest, it has taken 2 seconds. When lift is going up, then also it will take only 2 seconds. You will think that ball has gone up, lift is going up, so in the way, you will be catching the ball. So time taken will be less than 2 seconds. But no, it will take only 2 seconds. And not only velocity 5 meters per second. With whatever velocity you throw body up, okay, no? It will decide time. And the same time it will not depend upon velocity of lift. Lift may go with velocity 5 meters per second, or 20 meters per second, or 100 meters per second. Let lift should go vertically up, or let lift should go vertically down. Time taken is same. Time does not change. Why? A phenomena does not change when we move from one inertial frame to other inertial frame of reference. Before that, lift was at rest with respect to ground. Phenomena I told not change. It means that any physical quantity associated with that phenomena will not change. Your time which it has taken for entire flight, when it was 2 seconds, then when you are changing from one inertial frame to other inertial frame, it will not change. It will be 2 seconds. Lift is going vertically up with whatever velocity you want to take. Lift should go vertically down, but if it will be velocity, it will not change. That is the uniqueness of inertial frame of reference. But this time will change when you are moving from one inertial frame to another non-inertial or accelerated frame of reference. Now suppose lift is being accelerated. It is going vertically up with certain acceleration you take 2 meters per second squared. Now, will it take time 2 seconds? Answer is no. Now it will take less time. Why? Now, phenomena is changing. Any physical phenomena, beta. Not only I'm talking about motion. You take any phenomena, certainly it will change if you observe that phenomena from non-inertial frame of reference. To explain that phenomena along with real forces, see here, to get 2 seconds, you have considered only real forces. But to explain a phenomena in non-inertial frame of reference along with real forces, you are considering some fictitious imaginary force. From where this imaginary force is coming? Why we need that? Okay, all I will be explaining you in too much detail in Newton's laws of motion. So at this time, I'm talking about frame of reference. I told you it is of two types, inertial frame of reference, non-inertial frame of reference. Recapping that so that you can remember this, you need these concepts for learning kinematics as well as dynamics. Everywhere you need this frame of reference. Even for learning vector, you need that. Okay? A simple frame of reference I told you in vector chapter. Simple, basic, a vector A, if you are representing in a frame of reference, you are representing it by AXI, AYJ, plus AZK. Here, IJK are unit vector along X direction, along Y direction, and along Z direction. AX is component of vector A along X direction. AY component of vector A along Y direction. AZ component of vector A along Z direction. So you just see, here also you need a frame of reference. Just in brief, again, I am telling you, how many types of frame of references you have? Inertial frame, non-inertial frame. Inertial frame, Newton's laws hold good. Inertial frame is that frame of reference which is either fixed with respect to distant star or which moves with constant velocity with respect to distant star. For us, we are tiny dot, our motions are related to Earth, we are not studying motion in free space and all, so we will consider only those motions which are happening on Earth, so star we are replacing from Earth. Inertial frame is that frame of reference which is either at rest or which moves with constant velocity with respect to Earth. Any phenomena will not change, so that any physical parameter associated with the phenomena will not change if you move from inertial frame to another inertial frame. To explain any phenomena in inertial frame, you need to consider only real forces. You know about real and pseudo forces, na beta? How many types of real forces you have heard? You have heard about 4. Gravitational force, electromagnetic force, nuclear force. One more you have heard, weak of Fermi force. A Pakistani scientist, Pakistani born, okay, no? Abdul Salam, he has told no, weak of Fermi force is a part of electromagnetic force. So at present, we have only 3 real forces: gravitational, electromagnetic, and nuclear. In Newton's laws, I will talk about these forces in too much detail. What is the origin of force? How much interesting it is. All of you have known about Newton's third law, na? On the roadside, a person also knows every action has equal but opposite reaction. How much simple law it looks. But every action has equal but opposite reaction says you, whenever force will take birth, it will take birth in pairs. Am I right? No. Why? Why a force should take birth always in pairs? And how it is taking birth? Why we are not getting a single force? Why we will not have a single isolated force? What should be the origin of force? Think once. In real life, reaction always occurs after action, na? You have shouted on mummy, afterwards what mummy will do? Think, reaction is happening after action, na? But in physics, action and reactions are simultaneous process. Understanding me? Yeah? Both will take birth at the same time. If 2 forces are taking birth at the same time, when I was child at that time, from that time I have these doubts. Okay, no? If they are taking at the same time, which one should be called action and which one should be called reaction? Secondly, how they are taking birth? Why we don't have unified field theory? Gravitational force, electromagnetic force, and nuclear force, why we are classifying? Why not we would have a single force? You can explain any phenomena in the universe, known phenomena, with the help of only these 3 forces. Scientists are searching a unified field theory, a single force from which we can explain all the phenomena. In inertial frame of reference, you will take help of only these 3 forces. You will not consider any pseudo force to explain the phenomena. But in non-inertial frame of reference, to explain any phenomena along with real force, you are considering some pseudo force, which will be equal in magnitude, opposite in direction. I can explain you in too much detail for that. In Newton's laws, at this time, I'm interested in motion, so I have told you what is rest, what is motion. Right? In inertial frame of reference, what is happening? In non-inertial frame of reference, what is happening? What is non-inertial frame of reference? What is inertial frame of reference? Now, come towards rest and motion, which is part of kinematics. You can classify like kinematics and dynamics. These two parts. Newton's laws of motion will come in dynamics. In kinematics, you'll be studying about distance, displacement, velocity. Now, so many different types of velocities you have heard in 9th and 10th now. Uniform velocity, non-uniform velocity, mean velocity, instantaneous velocity. Right? You will have acceleration, uniform, non-uniform there also. Then, in one-dimensional equations of motions are there. V equal to U plus AT. You have heard, no? All I will be teaching you. Basics I will fully explain to you in this 1 month. S equal to UT plus half AT square. V square equal to U square plus 2AS. Someone had asked me, what is the need of these classes? But when you will be coming here in the month of June, no, we need at the time all these basic fundamentals. I'm not telling all of you are not knowing. In class 10th or those students who have taken foundation, in that they have heard about this, but we don't want to take risk. We want to explain all these things so that when you'll be coming in the month of June, yeah, it will become much easier for you to learn. Again, we'll be teaching you all these things. I have already promised you that first I'll be teaching you kinematics, dynamics. For starting that, we need differential calculus, integral calculus. In the beginning, mathematical tool will teach you. And physics teacher will teach you. Math teachers will teach later on. Integral calculus comes in second year. They will be teaching you integral calculus in second year. Some of you may be knowing integration x n dx, x n plus 1 by n plus 1. I want dx n dx, n x n minus 1. Basic first formula of differentiation integration. In kinematics, when we are starting, no, in the beginning only you use this. Clear to you? I'm starting now. Motion chapter, first unit. What is kinematics? Are you knowing kinematics? What is the difference between kinematics and dynamics? Both are related to motion, right? For kinematics, I'm quoting you a simple example. Suppose winter season is there. Okay, northern India, too much cold it will be. And you are traveling in a super fast train. Hey, this question is IIT asked. From that problem, I have created this example. So, you are sitting in a super fast train, foggy weather, early in the morning, 4:30, in your compartment, all are sleeping. You don't sleep. See through window. Outside, very mysterious environment will be there. Okay, no? See outside, foggy weather, mysterious environment. Your train is going at a very high space. Very high speed your train is going. Suppose your train velocity is u. The driver of train is not capable to see clearly track a bit far away. Suppose on the same track, a bit ahead, a bit ahead. The moment he has seen, let us take at a distance d, a passenger train is going. Undoubtedly, passenger train is there, its speed will be less. Let us take its speed is v. And your train is going at a very high speed. What will happen? The moment driver of your train, express train, had observed that on the same track a bit ahead in the same direction, a passenger train is going, what he will do? He would slam the brake. Beta, train is not like our scooter, no. You will apply the brake and it will be stopped. Train will be going. From this situation, in your brain, what is the first question coming in your mind? Undoubtedly, your first question will be whether collision will occur or not. From backside, this train will go and will hit this train or not. Am I right now? The branch of mechanics which gives the answer of this very first question is called kinematics. Understanding now? And after this, whatever question may come in your mind, the branch of physics which will give the answer of any other question, that's called dynamics. How brakes have worked? How much time brakes have taken to retard your express train? Am I right now? Yeah? That part you will study in dynamics. But very first question, collision will happen or not, you will be learning in kinematics. Kinematics is that branch of mechanics in which you study about motion of the body without considering its causes. What is the cause of motion? But when I was child, school teachers, they were very strict. If you have not done homework, no, they were giving a lot of punishment. So suppose any day I am not doing, homework, I was telling I will not go to school. So from backside father was telling, he was going to office, he was holding my hand, how will you not go? He was exerting force. How I was moving? I was moving because he was applying force. He was applying force. I was moving some distance and I was applying retardation. I was coming to rest. Again he was exerting force. What is cause of motion? Force, na? Yeah? And this force depends upon mass. The acceleration, whatever you are considering, it will depend upon the mass. If a small body is there, you will have larger acceleration. Big body is there, acceleration will be less. Same force you apply, there is a small stone and a big stone you hit. See? What will happen to you? You will be hurt more when you are hitting a larger stone. Right? The cause of motion is force. In kinematics, we will not study about force and mass. We will study about entire motion. We will study about velocity, displacement, acceleration, time, all these we will study. But we will not consider force and the mass of the body. The student has told me, sir, I understood. What did you understand? He is telling, sir, in kinematics, only we will eat mangoes, sir. From where mangoes are coming, we will not study. No, beta. In dynamics, you will eat mangoes also, and from where mangoes are coming, that one also you will study. In kinematics, you are correct. You will study. Only you will eat mangoes. Means you will study only about motion of the body without considering the causes. Clear to you? Understood? In dynamics, You are studying about motion of the body, and also you are studying about force, the cause of motion. Clear to you? I am starting the first unit of kinematics. Distance and displacement. Motion, in the beginning only I told you what is rest, what is motion. No, there is no absolute meaning of rest and motion, because there is nothing like absoluteness or idealness. Anything which is ideal, perfection, you'll never achieve in life. Never try to attain perfection, in my opinion. Try to go nearer to perfection, but never try to attain perfection, because no one can attain perfection. Nothing is ideal. Understanding me, na? Clear to you? So now, first unit of kinematics we want to start, that is distance and displacement. So, my next topic is distance. Okay? And displacement. You already know distance is a, first in the beginning, distance is a scalar quantity, displacement is a vector quantity. Okay? Suppose there is a particle. I am just taking a particle, started to move from A and it has moved to point B. Now, to go from A to B, there may be different path. A particle can go like this, a particle can go like this, and a particle can go directly like this. Okay, no? The total length of the path A to B, that will be length of the path. If you measure, that will give you distance covered by the particle in a given time interval. But displacement is a vector quantity. It is a directed line segment in between initial position and final position. If you take a two-dimensional frame of reference, this is x coordinate, y coordinate. Suppose this is point A and this is point B. If you take, this is R1 and this one is R2 vector, then A to B directed line segment, this will become, if you take R, it will be R2 minus R1. First, simple concept. Distance is length of the path tracked by the particle. Measure the total length of the path from your school to house. Whatever road, there may be various road to reach to your house. Okay, no? Measure the length of the road. That will give you distance covered. So distance covered depends upon the path, nature of path. Displacement will not depend upon nature of path. It only depends upon initial position and final position of the particle. Whatever path you take, if initial position is fixed, final position is fixed, displacement will remain constant. Distance covered depends upon path, displacement does not depend upon the path. Correct? If you take distance covered, usually always, it will be greater than displacement. Displacement will never be greater than distance covered. One condition is there. If suppose particle is moving along a straight line path, particle is going along this straight line path from A to B and is not returning, then length of the path is directed line segment A to B, and displacement is also same. Under only one condition, distance covered and displacement will be equal if particle moves along a straight line path without return. If it is returning, that matter is different. For example, A to B, if this distance is S, suppose particle has gone from A to B and again it has returned back here. It has returned A to B and again it had come from B to A, your displacement is 0. But distance covered will be S plus S. Length of the path you are measuring na beta. So you are going in this way S and again coming back S. Total distance covered is how much? 2S. Right now, the distance covered is 2S, but displacement is 0. Why displacement is 0? You have taken initial position, you have taken final position, both are same point, so it is 0. You can't say 0, you should say null vector. I mean to say you that displacement will never exceed distance covered in a given time interval. Only one condition is there, that distance and displacement will be equal. And that condition is particle is moving along a straight line path without return. Clear, na? Displacement may be positive, may be negative, may be 0. 0 that just now I have shown you. And now negative I am showing you. Suppose particle had started from A. Suppose this is origin. This side is x-axis I take. So this is 0. This side will be positive x. This side will be negative x. Now, particle had moved from origin to A. Suppose this distance is x1. And now from here it has returned back and it has reached here to point B. Now what will happen? Your particle is now in negative side, negative x-axis. So displacement becomes negative. And if particle is going like this in positive x direction from origin, any displacement you take, it is positive. So displacement may be positive, may be negative, may be 0. But distance covered will always be positive, because you are just considering length of the path. The particle is moving, it will be going on moving. It may go in positive direction, negative direction, any direction. Just you will have to take the length. The length will always be positive. So distance covered by a particle in a given time interval will always be positive, but displacement may be positive, may be negative, may be 0. Based on this, we can create so many fundamental questions. What will be the ratio of distance covered and displacement of a particle in a given time interval? I'll give you A, B, C, D. Greater than 1, less than 1, greater than equal to 1, less than equal to 1. You are taking ratio of distance and displacement of the particle in a given time interval. It should be always greater than 1 under one condition equal to 1. So answer will be greater than equal to 1. Simple question. Now, let us go for some more fundamental questions related to distance and displacement. Suppose a particle is moving in a circular path. Okay? In a circular path, particle is moving. I am giving you radius r. Particle had completed 3.5 number of revolutions. How many revolutions? 3.5. I want to know what will be distance covered and displacement. You know, length of the path is called distance. 3.5. You know na, circumference of a circle equal to how much? 2 pi r. 3.5. Let us see. I am taking first distance covered. The distance covered S, which is a scalar quantity, no arrow mark. If you take 1 revolution, distance covered 2 pi r. Second, 4 pi r. Third, 6 pi r. 3.5 means now it will come till here. Suppose it has started from A and finally it has stopped to B. Pi r. How much you are getting? 2 pi r plus 2 pi r plus 2 pi r plus pi r. Total 7 pi r. Am I right now? Now this 7 pi r, 7, 22 by 7 r, 7 cancel, distance covered 22 r. Understanding me? The distance covered, if particle is completing 3.5 number of revolution, it is covering 7 pi r, that is 22 r. But if you are talking about displacement, then you will be considering directed line segment from initial position to final position. Means it will start from A and directed line segment means A to B, direction decided. Right? Now, take the length of this directed line segment. No need to say to you now, R. And this is R. This is length of diameter. Length of diameter, how much? 2R, no? So your displacement is simply equal to 2R. Tell me, understanding now? Simple concept. Particle is moving on circular path. Calculate distance and displacement. Same problem I can give you by taking an arc. Let us suppose I am taking now a particle which has moved from A to B. So radius vector, this is R, this is R. Radius vector, I am taking subtending angle theta at the center. Now, you know, distance covered will be length of this arc, AB. And already you know, it will be R into theta. Right now? But displacement, this is R theta. Right? Now, I want displacement. Again, same directed line segment. You will go from A to B. Now, how will you get this length AB? Very simple technique I give you, beta. You just drop a normal. You are dropping a normal. This angle theta by 2, this angle theta by 2. Suppose your displacement is x. So this will be bisecting it, no? X by 2, x by 2. Now, this angle is theta by 2. Sin theta, you know, na? Perpendicular by hypotenuse. So you will have sin theta by 2 will be equal to x by 2 by r. X is displacement, magnitude of displacement. So this is x by 2r. X will be equal to 2r sin theta by 2. Yes or no? Tell me. 2r sin theta by 2. Same circle I have taken. First I have taken 3.5 number of revolution. It was easy. Now I am taking any angle theta. Now any value of theta you can take. Theta you can take 60 degree. Theta you can take 90 degree. You can easily calculate. Same distance covered r theta. Understood now? Suppose you take theta 90 degree. 90 degree, if you take, then you just see distance covered. I'm drawing here, beta. If you will take like this, particle is moving from A to B. Now I'm taking 90 degree. 90 degrees pi by 2, pi r by 2. And why not it will be pi r by 2? You know, total is 2 pi r. Half is pi r. So 1/4 will be pi r by 2. Pi by 2 is theta. So simple r theta. Distance covered will be r theta. Understanding me now? Yeah? And for calculation of displacement, you will be taking 2r sin theta by 2. If you consider a square path A, B, C, D. Suppose a square side is A. In a given time, a particle had moved from A to B and B to C. Now you want distance and displacement. Damn simple. You will be taking length of the path. AB plus BC will be distance covered. A plus A, 2A, that is distance covered. Now we want displacement. Same way, initial position and final position. So always remember, displacement only will depend upon initial position coordinate and final position coordinate. The easiest way, initial position and final position. I can say you in terms of vector also. Okay, no, I'll be telling you a bit later on. First, simple language, it will be magnitude I am talking about, distance covered 2A, and displacement, the length of this diagonal AC, magnitude of displacement, this will become simply root 2A. Tell me, basic concept related to distance and displacement, are you understanding? What is distance and what is displacement? You can easily calculate. I can take hexagon, I can take pentagon, I can take a triangle, any you consider, any path. Take total length of the path, it will help you a lot better when computing mean velocity or average velocity. When you talk about mean speed, average speed and average velocity, time taken will be same. Means denominator is same, but numerator will be changing. A very simple question is there. A particle is moving on a circular path. of radius r with uniform speed v. They are giving you uniform speed v. And they are asking you what will be average velocity if particle had completed 3.5 number of revolutions. So this concept of numerator means distance or displacement in same time interval will play very, very important role. Tell me, did you understand the basic concept related to distance and displacement? Did you follow? If you want now in vector form, then you will have to go for two position coordinate. Suppose initial position coordinate is x1, y1, z1. And final position coordinate in three-dimensional frame of reference, I am taking x2, y2, z2. A particle had moved from a point having coordinates x1, y1, z1, and it has moved to another point having coordinates x2, y2, z2. You want to know what will be displacement of the particle. Always we subtract initial from final. We will never subtract from final from initial. Then your displacement vector will become x2 minus x1i plus y2 minus y1j plus z2 minus z1k. This is about, displacement. Today, I have told you about distance and displacement, and these concepts will help us to understand speed and velocity. In tomorrow's class, I'll be giving you basic concept related to speed and velocity. Right? As I promised you, I will be making your all basic concepts clear. So CBC, concept building course, for me in other way is confidence building course. So that when you will be coming here with full confidence, you will be studying. In full swing, we'll be teaching you from the month of June. At this time, don't think we are teaching. We are just basics, fundamentals related to physics, I'm clearing. So that when you will come, it will become much easier for you to understand physics. Physics is very, very interesting. You'll enjoy when you'll be coming to our campuses. Thank you for today. One minute. I want to convey to you your next class, perhaps math class, will start after 10 minutes. So please wait for your math class. Thank you.
ठीक है. Huh? I start. Good morning, students. Today we'll be doing mathematics. In mathematics, the first chapter what we are going to study is number system. Okay, so this is a very basic chapter, or I'll say a basic topic to understand, in which we'll understand what kind of numbers, how many types of numbers are there in the number system, like natural numbers, whole numbers, integers, real number, all this kind of numbers. What are rational numbers, irrational numbers, which you definitely must have studied in 10th, but 10th or 9th, but we will revise it briefly, and then we'll try to understand and do questions on them. What kind of questions comes on number system, right? So let's start, right? The first type of numbers what we are going to learn is natural numbers, right? I think natural numbers. Okay, so what kind of numbers are natural numbers? Any numbers starting from 1, 2, 3, so on, right? Any positive numbers till infinity, right? Till infinity, we can say it's a natural number. So you don't need to write infinity also. You can just write like this. So 1, 2, 3, any kind of numbers, positive integers, right? Starting from 1 till the maximum number. That is known as natural numbers, right? Second, whole number. Second numbers are what? Whole numbers. Whole numbers are very similar to natural numbers, right? Very similar to natural number. But what is the difference? There is a very slight difference that in whole numbers there is 0 also included. So 0, 1, 2, 3, so on will be known as whole numbers, right? Natural numbers starts from 1 and goes till the end, but whole number starts from 0, including the natural number 1, 2, 3, right? So we can say from here that whole number, right? Whole number is a bigger set of number than natural numbers, right? Because it has extra 0 also, correct? So this is about natural number and whole number. Now we'll understand about integers, right? Integers. Okay, what are integers? Integers are nothing but all the negative numbers, right? -3, -2, -1, including 0, 1, 2, 3. Right? All the non-decimal numbers are known as what? Integers. Okay, negative, 0, and positive, right? So this is in integers, all the numbers. These numbers are what? Negative numbers. Negative integers, right? There is a 0, and then there is positive integers, right? So everything will be included in what? Integers. Okay, so now integer is also a bigger set than whole number, because you can see in integers from 0 till the maximum number they are also coming, and along with it negative numbers are also coming in integers, right? So natural numbers, whole numbers, and integers. Then the next thing is, fourth is, okay, I'll change the color. Okay, fourth is what? Positive integers. Positive integers is nothing but natural numbers. So positive integers are nothing but natural numbers. Okay, Positive integers are nothing but natural numbers, which we have already written here, right? One more thing, natural number is denoted by capital letter N, right? Capital letter N. Whenever we refer natural numbers, we refer it to be what? Capital letter N. Whole numbers will refer it to be what? With the sign W, okay? Integers, we generally refer it with the sign of Z, okay? Z actually means what? What does it denote? It denotes integers, right? And positive integer, if I want to denote, I will be writing Z plus, right? Z plus, or I can also say it to be a natural number, okay? Z plus will denote positive integers or also natural numbers, right? Next we'll go to the next slide, okay? Fifth, which is negative integers. Negative integers, right? What are negative integers? It will be starting from a very small number, then -3, -2, and -1, okay? So it will be starting from very small number, right? And will be going till what? -3, -2, and -1. And they will be denoted by what? Z minus. They will be denoted with what? Z minus, okay? So this is about negative integers, okay? Then the sixth kind of number is non-negative integers. Non-negative. Now what does it is saying, right? Non-negative means what? Non-negative means negative. We don't need negative numbers, right? So in integers, if I see in integers, there are negative, 0, and positive, right? So we don't need, in non-negative, I can say I don't need this negative numbers. So what exactly are we looking for? We are looking from these numbers, which are nothing but whole numbers, right? Which are nothing but whole number. What student does a mistake is they consider non-negative to be equal to positive, right? But this is not correct. This is a mistake, right? Non-negative is not equal to positive. What does non-negative means? Non-negative means 0, 1, 2, 3, so on, right? So it will contain positive and 0, because 0 plus positive numbers are considered to be what? Non-negative integers, right? Please remember this. Non-negative doesn't mean positive numbers. There is a difference, right? Similarly, just like non-negative, we will be having, so we can say it is as a whole number also, right? Then the next kind of number, seventh, right? Next kind of number will be what? Non-negative, so we'll say non-positive. So again, just think, just like non-negative integer, think whether non-positive integer, will it be equal to negative numbers? Will it be equal to negative number? No, right? Why? Because it will also have 0, right? So we can say it will be starting from smaller number to till here, then -3, -2, -1, and 0, right? In non-positive integers, what will be coming? All the negative numbers along with 0. So this 0 is extra, right? Because of which we can't say that non-positive integers are negative integers. Am I clear? Right? All these 7 kind of number, I think this is a very basic about numbers. Natural number, whole numbers, integer, positive integers, right? Then next is what? Negative integers, non-negative integers, and non-positive integers. Am I clear? Okay. Let's look at the next kind of numbers. Then we'll come to what? Next kind of number. So we'll be coming to 8th kind of number. We'll understand deeply about them tomorrow, but I'm just telling you right now what is rational number. Right? Rational number. You must be remembering from your school time, right? Like 8th or 9th, you must have learned the definition of rational number. What is a rational number? Any number, right? Any number of the type P by Q, where q, p comma q are integers, where p comma q are integers, and q does not equal to 0, right? Any numbers of the type p by q where p and q both are integers, but q, that is a denominator, cannot be equal to 0, are known as what? Rational number. Are known as what? Rational numbers. Now in rational numbers, all the integers, right? All the integers, fraction, okay, and terminating number. All these numbers comes in terminating or recurring numbers, right? Terminating numbers will be coming in what? Rational numbers, okay? So whatever types of number we have studied so far, right? All this will come under which umbrella? It will come under the umbrella of rational number. Am I clear? And they are denoted with what? Capital letter Q, okay? This will be denoted with what? Capital letter Q. So Q is what? Rational number. Okay. So all the integers, fraction, terminating numbers, right, will be classified as what? Rational numbers. Am I clear till here? Okay. Then the next kind of numbers is irrational numbers. So we'll be doing questions based on rational and irrational number, and we'll be understanding them tomorrow also. But right now we are just generally understanding what is a number system. So we are getting a brief idea about rational and irrational number. So what is a irrational number? Irrational number are the numbers which are non-terminating and non-recurring numbers, and non-recurring numbers are what? Irrational numbers. Okay. Generally they comes under under square root or cube root, and that too they have inside the square root or cube root they will be having a prime number. So say square root of 3, square root of 3, square root of 5, right? All this comes under what? Irrational numbers, right? Along with this there are two more special irrational numbers, right? One is e, right, and second is pi. Okay, pi you all must be knowing about it. Pi is, we approximately take it to be 22 by 7 or 3.14, but the exact value of pi is not defined. Okay, and e is a Napier's constant. All right, so this is about rational irrational numbers, and just like rational number, irrational numbers are denoted by what? They are denoted by q dash. Okay, they are denoted by what? Q dash. Am I clear about it? So irrational numbers and rational numbers are again the two types of numbers in the number system, right? And all the types of other numbers like this, non-positive, non-negative, negative, positive, integers, all are will come under which category? They will come under the category of rational numbers. Okay, now we'll learn about the last and the biggest set of number. Right, biggest set of number is what? Real numbers. Real numbers. Okay, real numbers. So what is the definition of real number? Real number means all the types of numbers that are rational or irrational numbers comes under the category of what? Real numbers. So real number is like the father of all the numbers, okay? And it is denoted by what? It is denoted by capital letter R. Okay, it is denoted by what? Capital letter R. So this is a biggest set of number in which there will be rational numbers also, irrational numbers also. Everything will come under the category of what? Real number, right? So just to revise it briefly, what we have learned so far. So first is a real number, right? In a real number, there are two types of number. One is rational and second is irrational, right? Q and Q dash. Q stands for rational, and irrational, it comes under the category of what? Real number. Real number is the biggest category of number. Am I clear? Then in rational numbers also, there are three types of number. okay, negative integers, 0, right, and positive, right, negative, 0 and positive. So this will be coming in what? Rational number. Along with it, there will be decimal numbers also, right, decimals or fractions also we can say. So this all will be coming under the category of what? Rational numbers, right? And in positive integers, right, this combined will be known as whole number, and this will be alone will be known as natural number. So this is a brief idea about what the types of numbers, all the kind of types of number in the number system, right? Let's move further and let's understand what other classification we can do on number system, right? Like even numbers, odd number, prime numbers, composite numbers. So these are different types of numbers. Let's understand one by one what exactly does all this means. Correct? So I hope everything is clear till here. Real number, rational, irrational numbers, decimal, negative, 0, positive, and then comes the whole number. This is a combine of 0 and positive integers. Okay. Okay, let's go to the next point. All right, the next kind of numbers what we are going to study is about even numbers. Okay, even numbers. So what is the definition of an even number, right? Think about it. You must have learned in your school that what is an even number, right? Numbers which are ending with 0, 2, 4, 6 and 8, right? Numbers which are ending with 0, 2, 4, 6, 8, right, are known as what? Even numbers, or we can also say it's a multiple of 2, right? All the numbers which are multiple of 2 will be classified as what? Even numbers, right? So I don't think there is a requirement of any example for even number, because all of us understand what is a even number. Okay, but just to revise it, I have written it. Numbers which are ending with 0, 2, 4, 6 and 8 are known as what? Even numbers. And there is no general denotion for even numbers, just like rational numbers, irrational numbers, real numbers. Okay, we generally say it to be what? Even number. Okay, then the next is what? Odd numbers. Then the next kind of number is what? Odd numbers. Okay, what kind of numbers are odd numbers? Numbers which are not even. We can, in one way of saying is what? Numbers which are ending with 1, 3, 5, 7 and 9, right? Numbers which are ending with 1, 3, 5, 7 and 9 will be known as what? Odd numbers, right? So in both even and odd numbers, negative and positive both type of number can come. Okay, we can also have even negative number, we can also have odd negative number, right? 0 will be classified as even number only. If only the number I am talking about 0, it will be classified as what? Even number. Am I clear? So I hope it is clear with even number and odd number, right? Now what are the possible combinations of numbers? Let's understand that, right? Like if I add two numbers, so will it be, what is the condition for it, that number to be even, that number to be odd, or multiply or divide? Let's understand them, right? What are the possibilities? Okay, so let's see them one by one. All right, so if I add, right? If I add or subtract an even number with an even number, right? Add or subtract an even number with an even number, I am going to get an even number, right? I'm going to get an even number. Similarly, if I am going to add odd and an odd number, both of the same type, even and odd or odd, right? Add or subtract, then also I'm going to get what? Then also I'm going to get a what? Even number. So for example, if I want to consider, just to explain you, that 1 plus 3 will give me 4, which is an even number, right? Which is an even number. 1 is what kind of number? Odd. This is also what kind of number? Odd, but it is giving me what? Even number. Right? It is giving me an even number. Then secondly, if I take two even numbers and subtract them, let's say if I take 10 minus 8, so what I am getting? 2. Right? What am I getting? 2. Again, I can add them also, it will not change. Why? Because it's, I told you, even minus even will always give you even. Right? So if we add any two kind of number, like two similar kind of number, like even plus even or odd plus odd, or plus minus, both will consider, then the type of number what we are going to get is always going to be an even number. Right? I hope it is clear to everyone. Next thing is what? Next, if I add or subtract two different kind of numbers, then let's understand what happens. Different kind means, let's say if I add an even and an odd number, right? Even plus minus odd. Then think for a minute that what will happen if I add two different kind of numbers, then even plus minus odd, right, will give me always an odd numbers, right? It can be odd plus minus even also, not matter, but even plus minus odd will always give me an what kind of number? Odd number, right? An example for this will be, you can think of any number, let's say 3 plus or minus 4. So either I'll get a 7 or I'll get a minus 1. Anyway, it is going to be a odd number, right? It is going to be a odd number. Why? Because as I told you, that this is an odd number and this is a even number. So odd plus minus even will always give me an odd number, right? So on for addition and subtraction, I hope it is clear to all of you that if we add any two type of numbers, similar kind of numbers, then we'll be getting a even number, right? But if we add or subtract two different kind of number, that is one is even, other is odd, then it will become an odd number. All right, let's go to the next point. Let's see what happens when we multiply two numbers. Okay, so this we will do one question on based on this thing. That is why I'm explaining to you right now what will happen to this. Okay. All right, so let's see what happens if I multiply or divide two type of number. So again, third case, right? Third case, right? In third case, we'll see if I divide or multiply, right? Even divided by even, odd divided by odd. No, wait. Even divided by even, okay, or even multiply by even. In division, we can't say anything. So right now, we will not take a case of division. We'll take a case of multiplication. So if I say even with even, right? Even into odd, right? Even into even or even into odd will always give me a even number. Will always give me a what? Even number. So if in multiplication I have even one even number, right? Then the ultimate product will going to be what? A even number, right? At least one even number I have in the product. So if I'm multiplying, let's say 5 numbers, and I'm having one even number in it, then the ultimate product is going to be what? Even number. All right, but next. So for example, for this I'll say, let's say 2 into 5, right? 2 into 5 into 3. So what I'll be getting? 30, which is an even number. Why? Because I have multiplied with an even number. And if any one even number is there, irrespective of what odd number or even number I am multiplying, I will get the ultimate product to be what? Even number. Okay, then next fourth. In fourth, we'll see if I multiply two odd numbers, right? If I multiply two odd numbers, then I'll be definitely getting a odd number, right? Odd into odd, we cannot ever become even. Okay. So, for example, 3 into 5. 3 into 5 will always give me what? 15. 15 is what kind of number? 15 is an odd number. Right? 15 is what kind of number? An odd number. So I hope it is clear, right? What are the operation on even numbers. So I'll revise it again once again. What happens generally? So even plus minus even or odd plus minus odd will give me an even number, right? And even plus minus odd will always give me a what? Odd number, right? Next, even into even, right? Or even into odd will always give me a even number. So if I multiply any number with an even number, I will always get an even number. Then if I multiply two odd numbers, then the product will be what kind of number? Odd numbers, right? I hope it is clear right now what are the type of number, even numbers and odd number. All right. Zero is coming. Zero, if somebody has a doubt about zero, I already told you zero comes under the category of even number. Okay. Zero comes under the category of even number. All right. Let's go to the next topic. Okay. The next topic is prime number. Right? Prime number is a very interesting type of number. Okay. So what does prime number means? Think about it for a second. What does prime numbers mean? Okay. I definitely think that all of you must be remembering something about prime numbers, right? अच्छा भूल गया था okay, then prime numbers, right? What is a prime number? Let's understand that. So any numbers which have only two factors, right? Any numbers which has only two factors, one is 1 and the number itself, is known as what? Prime numbers, right? Is known as what? Prime number. For example, I can say 2 is a prime number, right? I can say 3 is a prime number, 5, then 7, then 11, then 13, then 17, right? Like this, all 19. Like this, all kind of numbers will be what? All so on, right? So on will be a what? Prime numbers. Why? Because all these numbers will have only two factors. One themselves, that is 2, and the other number is 1. That they are divisible by themselves, either by themselves or the number 1. So those kind of numbers are what? Prime number, right? Some people must be thinking, sir, why 1 is not coming here? 1 should also be coming in this. No. Always remember, 1 is not a prime number, right? It is actually neither, 1 is neither prime nor composite. Okay, what is a composite number? I'll explain it in a while, but always remember that 1 is neither prime or composite. Okay, so apart from 1, all the numbers which we are getting here, which are divisible by themselves or 1, is known as prime number. All right. Now, one interesting fact about prime number is that all the prime numbers, right? All the prime numbers after 5, right? After 5 will be of the type 6n plus or minus 1, right? Will be of the type 6n plus minus 1. Okay, this is a very interesting fact. What I am trying to say, please try to understand. All the prime numbers from 5, right, will be of the type either 6n plus 1 or 6n minus 1. Okay, so for getting 5, I am putting 1, right? 5 and 7 I will get when I put 1, right? When I put 2, I will get 11 and 13, right? When I put 3, I'll get 17 and 19, right? But when I put 4, right, when I'm this, I put n equal to 4, see, one number I will get as 23, the other number I will get is 25, which is not prime. We all know 25 is a square of 5. So 25 is not a prime number, right? Then how can I am saying that 6n, all the prime numbers are of the type 6n plus minus 1? Please try to understand. I am not saying that all the numbers of the type 6n plus minus 1 numbers are prime number. Okay, that is not true. That is not necessarily always true, that all the numbers of the type 6n plus minus 1 will be a prime number. But all the prime number from 5 will be classified as what? 6n plus minus 1. The reverse may not always be true. Okay, so I hope it is clear now, right? So if you need to check any number is of prime number or not, you just need to check whether it is coming under the category of 6n plus minus 1. Okay, I hope it is clear. And one more thing, 1 is neither prime nor composite. Okay, 1 is neither, this is a very, very, very important fact, then 1 is neither prime nor composite. Okay, then this is the first, you can say a note, okay, a small note that 1 is neither prime nor composite. The second thing I wanted to say, right, second thing is what? That 2 is the only even prime number. 2 is the only even prime number. Right? There is no other prime number than 2. Right? 2 is the only even prime number. Then the next point, 3 is the smallest odd number. 3 is the smallest odd prime number. Right? 3 is the smallest odd prime number. Am I clear? Right? About all these three, note that 1 is neither prime nor composite. 2 is the only even prime number, and 3 is the smallest odd prime number. Right? And I will clear one more time that all the prime numbers from 5, right, from 5 will be of the type 6n plus minus 1, where I can say n belongs to natural numbers. Right? N belongs to what? Natural number. But the vice versa is not true. What do I mean by vice versa? Vice versa means all the numbers of the type 6n plus minus 1 will not be a prime number. This reverse is not true. Okay, we saw that 25 is a type of number 6n plus minus 1, but it is not a prime number. Okay, so I hope it is clear about prime number. What does prime number mean? Okay, and these are three important notes on prime number. Let's go to the next type of number. Right, next kind of number, which is a composite number. Okay, composite number. So what is the definition of composite number? Composite number stands for one more thing, that all the non-prime numbers will be classified as composite number. This is a very simple definition. But the other definition is what? Any number having more than two factors. Right, will be classified as what? Composite number. Will be classified as what? Composite number. So for example, let's say 4, right? 6, then 8, then 10, then 12. All these numbers, right? 4, 6, 8, 12. In fact, 9 also. Right? I forgot in the middle, 9. Right? This will be classified as what? Composite number. All these numbers will be composite number. Why? Because see, 4 has a factor of what? 1, 2, and 4. 6 has 1, 2, 3, 6. Right? Like that 10 has 1, 2, 5, and 10. Right? There are so many factors. So that's why they are not prime numbers. Because for prime numbers, there should be only two factors. One, the number 1, and the second, the number itself. Right? Now, this is about composite number. For composite number, remember one note, that 4 is the smallest composite number. right? 4 is the smallest composite number. Okay, am I clear? So 1 is neither even nor composite, 2 is the only even prime number, 3 is the smallest odd prime number, and 4 is the smallest composite number. So 1, 2, 3, 4. I hope now prime number and composite number is clear for all of you. Okay, so first we are understanding the theoretical part and then we'll be doing the questionnaire part. Okay, so this is about the composite number. Okay, then the next kind of numbers what we'll be learning is co-prime numbers, right? The next kind of numbers are what? Co-prime numbers, co-prime or relatively prime. Right, co-prime or relatively prime. So this is a very confusing term, co-prime and relatively prime. Many students are confused about them. So please try to recall what is the definition of co-prime numbers. Right, I will tell you the exact definition. Two numbers are said to be co-prime, if their HCF is 1. If their HCF, what does HCF means? HCF means highest common factor is what? 1. Right? Highest common factor is what? 1. For example, I can say 2 and 3, right? 2 and 3 are what kind of number? Co-prime or relatively prime numbers. Okay. Then I can say 4 and 3 also is what? Co-prime or relatively prime number. Why? Because their HCF is 1, right? Now mind it is not necessary that both the numbers have to be prime. 4 is a composite number and 3 is a prime number, but they themselves, right, are what? Co-prime or relatively prime. Are you getting what I'm trying to say here? That 4 is a prime number and 3 is a composite number, but they both together form what? Co-prime numbers, right? So it is not a necessary condition that for two numbers to be co-prime, they have to be both prime or they have to be both composite, right? Anything is possible, just their HCF has to be how much? Their HCF has to be 1. Okay, that is the only condition for two numbers to be relatively prime or co-prime. Right. So one more example if I want to give here is, right, 4 and 9. Right, 4 and 9. Now both the numbers 4 and 9, right, 4 is also a composite number, 9 is also a composite number, but they themselves are what? Relatively prime number. They are what? Relatively prime or co-prime. Why? Because there is no common factor apart from 1 in between 4 and 9. Alright? So don't be confused with the word just prime, right? Because prime numbers gives you that idea that the numbers have to be prime. It is not necessary, right? Co-prime means what? That their HCF is going to be 1. That's it. That number, those numbers can itself be a prime and composite, composite or composite, or both the prime numbers, right? Any combination is possible for those numbers. Am I clear? So this is about what? Co-prime or relatively prime number, right? Then we'll go to the next slide, last kind of number, and then we'll be practicing questions on whatever theory we have studied today. So we'll be practicing questions based on it. All right, let's do the last kind of number, which is what? Twin prime number. Okay, the next, yes, twin prime number. Right, twin prime number. Okay, now what is the definition of twin prime number? Right, if the difference between two prime numbers, if the difference between two prime numbers is 2, then it is known as what? Twin prime number, right? For example, 3 and 5, right? 5 and 7, right? 11 and 13. So all these kind of numbers will be known as what? Twin prime numbers. So this is the last kind of number, as I told you, that what we are going to study today. This is twin prime numbers. All right. This word twin prime will be what? Very rarely used, but definitely it can be used. It can be present in the questions. Okay. Now we have learned all the types of number as what we wanted to learn today. Now we will be practicing question based on this. Okay. Now how does this theory will comes under the question, right? Inside the question we'll understand that. Okay. So let's see a few questions based on that. Okay. So I'll write few questions. I hope it is clear to everyone right now. Or I'll do one thing first. I'll revise everything what we have done so far, right? It will be otherwise confusing if we directly jump on the questions. Right. So the first in number system, right? First we understood about natural numbers, then whole numbers, then integers, and then positive integers, right? Natural number is represented by capital letter N, then whole number by W, Z, and then Z plus. Okay. Then next we understood that what is a negative integer, right? What is a non-negative integer? 0, 1, 2, 3 are known as what? Non-negative integers, which we also say it can be a whole number. Non-negative integers are not positive because there is an extra 0 in it, right? That's why it is, we cannot say just non-negative equal to positive. Same logic, non-positive integers. Non-positive integers cannot be said as negative because we have an extra 0 in this. Okay. Then next rational numbers, right? Any number of the type P by Q, where P and Q are integers and Q does not belong to 0 is what? Rational numbers, and they are represented by what? Capital letter Q. Okay. Then we have irrational numbers, which is denoted by Q dash, non-terminating and non-recurring. Any number in the root or prime number is there, then we say it's an irrational number. There are two special irrational numbers. One is E and second is pi. All right. Let's go to the next slide. Oops. Next slide, right? Even numbers. Numbers which are ending with 0, 2, 4, 6, 8 or are multiple of 2 is known as even numbers. Numbers which are ending with 1, 3, 5, 7 and 9 are known as what? Odd numbers, right? Then operation on even and odd. One even and one, if both the numbers are even or both the numbers are odd, then we add or subtract them, we're going to get an even number, right? We gave an example of this. Okay. If one number is even, other is odd, then we will say we'll get an odd number. Okay. We're going to get an odd number. Then what if we multiply? While multiplying, if we get just one even number, then irrespective of whether we are multiplying with an even number or an odd number, I am going to get a what? Even number, right? So to get an even number, I should have at least one even number in the product. Then product of two odd numbers is going to be an odd number. Okay. If we don't have any even number, then the ultimate product will be what? Odd number. Then prime numbers, right? Prime number is a very important kind of number. Any number which has only two factors, one, the number 1, and the number itself is known as a prime number. For example, 2, 3, 5, 7, 11, 13, 17 and 19, so on. All right. Then 1 is neither prime nor composite. Okay. Second, 2 is the only even prime number and 3 is the smallest odd prime number. Okay. Then next point is what? That all the prime numbers more than 5 will be of the type 6n plus minus 1. Right? Will be of the type 6n plus minus 1, where n belongs to natural number. But not all the numbers which are of type 6n plus minus 1 will be a prime number. We saw an example of 25. Right? One more example is what? 35. Right? So 35 is what? 6 into 6 minus 1. But this is not a prime number. Okay, so we can't say just all the numbers of the type 6n plus minus 1 will be a prime number. We can't say that. Again, I am repeating it. Okay, because many students get confused of this fact. Next thing, right? Next thing what we have learned is composite number. Any number having more than 2 factors, right, is known as what? Composite number. Like 4, 6, 8, 10, 12, and we forgot about 9, so we can say 9 also, right? We saw that 4 has a factor 1, 2, and 4. 6 has a factor 1, 2, 3, 6. And 10 has a factor 1, 2, 5, and 10. Okay. Now, one more important note is that 4 is the smallest composite number, right? 4 is the smallest composite number. All right. Then the next point. Next point is what? Co-prime or relatively prime. Right? What are co-prime or relatively prime numbers? Two numbers are said to be co-prime if their HCF is 1. It means they have no common factor other than 1. Okay. For example, 2, 3, 4, 3, right? 4, 9. 4, 3 and 4, 9 are an example of co-prime number, but they are not, they don't have any common factor. Okay. But they themselves are what? Composite number. Okay. So don't be confused with this word prime. All right. And the last kind of number is the twin prime number, right? Twin prime numbers. Right? Twin prime numbers. What are twin prime numbers? If the difference between two prime numbers is 2, then we can say that they are what? Twin prime numbers. Okay? Like 3, 5, 5, 7, 11, 13, right? One more example is 17 and 19. All these numbers are what? Twin prime numbers. Okay, now let's go to the next part, okay, which is of questions. Okay, now we'll be doing some example based on the theory what we have learned so far. All right, let's come to the examples. I hope everyone understood the theory of the questions, like whatever theory we have done so far. Now I'll be applying those theory to solve the questions. Okay, and then we'll solve some questions from your exercise also, right? Worksheet. Okay, so the first question is, if 2009 is equal to P to the power A, Q to the power B, where P and Q are prime numbers, then P plus Q is equal to what? Then P plus Q is equal to what? So see, they have given 2009 as a product of two numbers, right? Product of two prime numbers. All right. It means that this P and Q are what? Prime numbers. Now, 2009, right? 2009 is actually an odd number. So definitely P and Q can't be none of them will be 2. Okay. So it will be either 3, 5, 7, what we'll see. Okay. So if I want to factorize 2009, right? So if I see it is going with 3, right? If I check if it is going with 3, it is not going with 3, right? Then with 5 also not possible. If I try with 7, right? If I try with 7, let's see whether we get something or not. Right? 3 and 5 are not possible. So 7 if I do, I'll get 2, then 60 will be getting 8, and then I'll be getting 49, 287. Right? 287. Am I clear? For 7. Okay. And then again, if I divide with 7, I'll be getting 7 here, and then it will be 4 and 1. Now 41. 41 is a prime number, right? 41 is what? A prime number. So we can't further factorize 41. Okay. That's why we can say that 2009, right? 2009 is actually 7 into 7 into 41. All right. 7 into 7 into 41. So we can say it is equal to 7 square and 41 to the power 1. Right? 7 square and 41 to the power 1. So if I compare now, right? So we can say P will be equal to 7 and Q will be equal to 41. Right? P will be equal to 7 and Q will be equal to 41. Someone can say, sir, why are you writing P to be 7? You can also write P to be 41 and Q to be 7, right? But what are they asking? They are not asking about anything about P and Q. They are asking their sum. They are asking their sum. So the sum of both P and Q in either of the case, right, will be how much? 48. Right? It will be how much? 448. I hope this question is clear to everyone, that we have understood about prime numbers. Now it is clear to how to solve this kind of question. Let's see one more example of this. Okay, next example. The number of prime numbers, less than 10, is what? P. And the number of composite number less than 15 is Q, right? Then P plus Q equal to what, right? Please, all of you, I'll just give you 2 minutes to solve this question. Okay, this is an example question. So please, whatever we have learned so far, try to apply it. The number of prime number less than 10 is how much? P they have given. And the number of composite number less than 15 is how much? Q. Then they are asking P plus Q equal to what? Please try to solve it. Okay, right, list down all the numbers, all the prime number less than 10 and all the composite number less than 15, right? Please solve it, everyone. Okay, I'll give you 2 minutes and just write your answers in the notebook. Okay, I'll give you 2 minutes. Okay, please solve it. Okay, I hope all of you have solved this question now so far, right? So let's see what are the prime numbers, right? Prime numbers, I'll take a different color. So prime number less than 10, what will be coming? 2, right? 3, 5, 7, okay? Someone will be thinking 9. 9 will not be coming, right? Only 2, 3, 5, 7. These are the only numbers, prime number less than 10. So we'll say P will be equal to 4, right? P is how much? It is equal to 4. Then next, prime number is done. Then next comes composite number. Composite number less than 15, right? Then first number will be what? 4. Then will be what? 6. Then 8. Then 9. Then 10. Then 12. And then last, till 12 only it will be coming, right? 4, 6, something we missed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Correct. Okay. Anything we are missing here? 9, 10. Okay. One more number we are missing here is 14, right? 12 and then 14. So Q will be equal to what? 7. Right? Q will be equal to what? 7. Less than 15 they are saying. So we were missing 14. Now P plus Q will be equal to what? P plus Q will be equal to 4 plus 7, which is means 11. Right? 4 plus 7, which means what? 11. So I hope this question is also clear based on prime numbers and composite number. Okay. Next question. One more question we'll do of this. Let P and Q be the number of natural numbers less than 20, right? Natural numbers less than 20, and this is and are prime and composite respectively, right? Prime and composite respectively, then find the value of 20 minus p minus q, right? 20 minus p minus q, right? This is a very interesting question. Let's see. In this question, the answer is very simple, but I want to see the approach, how you guys are doing. Okay? So please try this question. Let p and q be the number of natural numbers less than 20 and are prime and are composite respectively. Then find the value of 20 minus p minus q. Okay? So they are saying that p is a prime number and q is a composite number. Okay, so what will be the value of 20 minus p minus q? All right. So one way of doing this question is that you write all the numbers less than 20 which are prime and then composite and then subtract it from what? 20, right? This is one way of doing the question, but I don't think that is a smart way of doing it. Why? Because we know that any natural number will be definitely of the type prime or composite, right? It will be definitely of the type prime or composite. So if I subtract all the numbers, right, from 20, okay, so the only number left which is not a prime nor a composite number less than 20 will be just 1, right? Because I told you in the start only that 1 is the only even, 1 is not the prime nor the composite number, right? So only number which is not prime nor composite, right, is for 1, right? So the answer will be how much? 1. Understood? This is a very interesting question. Some people will do like this, that they will list all the prime numbers, right? So all the prime numbers, if they list 2, 3, 5, 7, 11, 13, 17, and 19, right? And then if they list composite number, so it will be how much? 4, 6, 8, 10, 12, 14, 15, 16, and 18, right? So total this is how much? P is how much? 1, 2, 3, 4, 5, 6, 7, 8, right? 8 prime numbers are there, okay? And how many composite numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So Q is how much? 9. I think we missed few numbers here. 2, 3, 5, 7, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. So we will get 9 and we'll get an answer has to be at 1. Understood? All of it is clear? Okay, next question. Now this question is very, very interesting. Okay, let's do this question. What is this question? Difference of squares of two odd integers, okay, is always divisible by, okay, there are 4 options given there. First is 3, B 4, C is 16, and D is 8. Okay, please try to solve it. I'll give you again 2 minutes. Difference of squares of two odd integers is always divisible by either 3, 4, 16 and 8. Okay, please try to solve the questions and get your answers. See, odd number will be always classified as 2k plus 1 or 2k minus 1. This is the only hint I am going to give it to you, right? It will be classified as 2k plus 1 or 2k minus 1. Or you can say why k we have taken. So you can say any number will be of the type 2m plus 1 and 2n plus 1, right? Where m and n both are what? Integers. So just try to do these questions based on this hint. Odd number is what? 2m plus 1 and 2n plus 1. Okay, so how we will do this? Difference of squares of two odd. Try to do the square of these two numbers and try to do the difference. Okay, try to do the difference. Let's see what answers do you guys get. Please try it, all of you. Right, I'll give you 2 minutes to solve it. So 2m plus 1 whole square, right, difference will be 2m plus 1 whole square and 2n plus 1 whole square, right? 2m plus 1 whole square and 2n plus 1 whole square. Okay, so what will be the answer? 3, 4, 16 or 8. Okay, you can do this question in one more way. The objective way is to do that is what? Just take any two odd integers, subtract them and get the answer, right? But that is not always going to be give you the correct answer, right? Sometimes it can vary. So, okay, I think enough time given. Now I'll solve this question. 2m plus 1 square minus 2n plus 1 square. If I open this, I'll get 4m square, sorry, 4m square plus 4m plus 1 minus 4n square minus 4n minus 1, right? Now 1 and 1 cancel, right? I can combine these two and I can combine these two, right? I can combine these two and then combine these two. So what will I get? 4 into m square 4 into m square minus n square plus 4 into m minus n, right? Now in both of this I can write 4 into m minus n into m plus n plus 4 into m minus n. Again I think you can see something common, right? Some factor common. This 4m minus n is common in both of them. So if I take it common, right, what will I get? I'll get it to be equal to what? 4m minus n. From this side of this, I'll be left with this one. So it will be m plus n. And from here, nothing will be left. So it will be m plus n plus 1. Right? 4 into m minus n into m plus n plus 1. Okay. Now please try to understand. Okay. Now from here, we can see that there will be one factor at least, which is what? 4. Okay. So there will be one factor at least 4. So see, 3 is out of the question only. Right? Because any number which is a multiple of 4 will, how it will be only 3. Okay. So now see whether m minus n or m plus n plus 1. Right. Now see what are the possibilities. We know that, see, we can say that m comma n can be both odd or odd, can be both even, right? Or can be one odd and other is even. Okay. Please try to understand this. If both are odd, then I can say that this will be an even number, right? If this is an even number, if in these two cases, both are odd and both are even. In either of this case, their subtraction is an even number, right? and any even number means it will have at least a factor of 2. So that 2, right, that 2 into this 4 will give me what? 8 into something, right? Will be giving me what? 8 into something. All right. Now, if one is an odd number and other is an even number, right? One is an odd number and other is an even number. In this case, right, odd plus even, this thing will be an odd number, and odd plus 1 again will give me an even number, right? Odd plus 1 will give me an even number. So if it is an even number, it means this will also have a factor of 2 in it. So this 2 into this 4 will give me what? 8 into something, right? This will also give me what? 8 into something, right? So it means that difference of squares of two odd integers will always be having a factor of what? 8, right? That is why the answer is what? D. That is why the answer is what? D. I hope it is clear to everyone, right? This question. It's a very interesting question. Okay, I'll again explain what I have done here. So I gave you a hint that for considering any two odd integers, I have taken two example, 2m plus 1 and 2n plus 1, right? As given, I have squared them and made a difference. So I have got 4m square plus 4m plus 1 minus 4n square minus 4n minus 1, 1 and 1 subtracted. Then again, I have combined 4m square and 4n square. I got 4m square minus n square. From here 4m and 4n. So I got 4m minus n. Then again I took something common. So I will get 4m minus n into m plus n plus 1. Right? Now this number m and n will be both odd. These numbers will be either odd, or this number will be even, or this, oops, sorry. This number will be both odd, both even, or one odd, one and even. So we saw that if in these two cases, right, this number will be an even number will have a factor of 2. So 2 into 4 will give me what? 8. Okay. And if one is odd and other is even, then at least this one will be even number. So it will be having a factor of 2. So again, this will give me what? 8. All right. So I hope this is clear to everyone. Now let's solve one more example and then we'll practice question from your worksheet. Then I'll give you a few homework for tomorrow. Okay. Let's do one more question. Next question. If m square minus n square equal to 7, right? M square minus n square equal to 7, where m comma n belongs to z, right, integers, then the number of ordered pair m comma n is, number of ordered pair m comma n is, right? Option A is even number, right? Option B odd, option C prime, it is a prime number, and option D, it's a composite number. Okay, so please try to solve this question. If m square minus n square is equal to 7, right, where both m and n are integers, then the number of ordered pair m comma n, how many such ordered pair will be possible, right? It is a even number, odd number, prime number, or composite number. Please try to solve it. Please try to solve it. Again, do in the same way, right? M square plus m minus n square is given. So what I can do, I can write it to be equal to m plus n into m minus n equal to 7, right? M plus n equal to m minus n into m minus n equal to 7. So please try to solve this. How can I get 7 as a product of two numbers? 7 is a prime number, right? So what I can do, I can make a cases. Case 1, m plus n into m minus n will be equal to 1 into 7, right? This is first case, right? Second case, I can write m plus n into m minus n is equal to 7 into 1, right? Third case, I'll write it here. Third case, m plus n into m minus n is equal to minus 1 into minus 7, right? And fourth case, m plus n into m minus n is equal to minus 7 into minus 1, right? There are 4 cases. So let's, in these 4 cases, how many different values of m and n are coming? Let's understand, okay? So see, if I solve this, I'll have m plus n equal to 1 and m minus n equal to 7, right? So if I add them, I am getting 2m equal to 8. So it means m will be equal to 4. If m is 4, I can say n will be equal to minus 3, right? So one ordered pair is how much? 4 comma minus 3, correct? One ordered pair is how much? 4 comma minus 3. If in this case, if I see, it is m plus n equal to 7, m minus n equal to 1, okay? M plus n equal to 7 and m minus n equal to 1. Again, if I add them, right, I am going to get m will be equal to 4, right? But here in this case, n will be equal to 3, right? So one more ordered pair, different ordered pair will be how much? 4 comma 3, right? 4 comma 3. Next, m plus n equal to minus 1 and m minus n is equal to minus 7, right? If I solve this, I'll get m is equal to minus 4, okay, minus 4, and here I'll get n is equal to minus 3, okay? Yes. So one more order pair will be minus 4 minus 3, right? Minus 4 and minus 3. Then the last one, if I solve, which will be m plus n equal to minus 7 and m minus n equal to minus 1, right? If I add them, again I am going to get m to be minus 4, but n, this time I'll get it to be 3, okay? So one more ordered pair will be how much? Minus 4 comma 3, minus 4 comma 3. So how many ordered pair, number of ordered pair is how many here? 4, right? 1, 2, 3 and 4. So the number of ordered pair is how many? 4. Now 4 is what kind of number? One, it is an even number, and second, it is a composite number, right? It's an even number, and second, it's a composite number. So the answer is what? A and D, right? You must be thinking, right? You must be thinking that how can one question have 2 options correct, right? This is one pattern of IIT JEE Advanced, right? In which more than one options can be correct, all right? So it's not always necessary that only one option out of the given 4 options, only one option will be correct. There is a possibility that more than one. So any 2 of them can be right, any 3 of them can be right, or all of them can be right, right? So all these possibilities are there. So it is not likely that only one option is correct. There can be more than one option also. So A and D, all right? So we have almost come to the end of the lecture, and we have completed the theory and the questions. Now I'll be doing some questions from your worksheet, okay, which is your CBC booklet. I hope all of you have received the book. If it is not, then you will get it, right, soon. So I'll be giving you some homework from it. So come to page number, those who have the book, please come to page number, in the CBC book, please come to page number 55, right? In 55, day 1 worksheet, right? In 55, day 1 worksheet is homework, okay? Day 1 So we can, as we have some time left, we can do few questions from this, starting from now, right? So these questions are all the 50, I think how many questions are there? Yeah, page number, I'll write it here. Page number 55 and 56. Question 1 to 15, homework, right? So we'll discuss this tomorrow in the class, right? Before going to the next theory, we'll be doing those questions. We'll be discussing all the questions tomorrow, right? And let's start doing the questions, okay, from here. One or two questions we'll be doing it together as we have some time left, okay? So we'll be doing this question together. Let's do one more question. So question number is 1, right? Question number 1 from your CBC book, day 1, right? Worksheet day 1, okay? Number of, I'll write the question if some of you don't have the book. So number of prime numbers, less than 10 is P. Is how much? P, okay? And I think this question we have already done. And number of composite number less than 15 is Q, then P plus Q is equal to what, right? This question we have done already. I'll show you here. Yes, this question, right? It is the same question. The number of number less than 10 is P and the number of composite number less than 15 is Q. The first question answer we already know. It is how much? 11, right? So the answer, I'll directly write the answer. What is the answer for this? It is 11. Right? We have done this question already. So that is why I directly wrote the answer. Number of numbers will be how much? 11. Acha, one more thing. That if you guys are doing the question or you have missed any particular class, then what you can do? You can go to the nearby center. There will be a set of faculties available in the centers from 2 to 5 o'clock, okay, to clear your doubts or to explain you one-on-one, okay. So you don't need to call or take any appointment. You can directly go to the center and there will be a set of faculties in the nearest center who will explain you any doubt regarding to the theory, okay, if you are not able to understand in the class something, or if you have any questions which you are having a doubt, then you can discuss that also with the respective teacher available at your nearest center, okay. Again, I am saying the timing is from 2 to 5, as from 9 to 1 o'clock we are having this online classes. From 9 to okay. So as I was saying, you can go to a nearby center from 2 to 5 because the classes are from 9 to 2 for biology students. For mathematics, it is for 9 to 1, but biology class is till 2 o'clock, right? So I think 1 to 2 also there is one more class for zoology, right? I think after 1 o'clock there will be a 10 minutes gap. So from after that they will be having a zoology class, all right? So you can always go to the centers and can discuss the doubt with the faculty, okay? And anyway, I'm going to discuss all the questions again tomorrow in the class, okay? So whatever homework I have given, this 1 to 15, I'll be discussing all these questions tomorrow, okay? So the first question though is already same as what we have done in the class, so there is no need to do the first one. We have already done the first one. I think you can do the rest 14 questions and we'll discuss it, we'll solve it tomorrow. All right? Okay, bye-bye. Thank you everyone.
Good afternoon, students. So, welcome to the 2-year academic journey with Resonance, and I'll be dealing with the biology in your online session, botany. Okay. So let us start with the very first chapter, and that is cell, the unit of life. So we are already familiar with this chapter in our previous classes also. In our lower classes, we have talked about the cell, unit of life. So here we are going to talk in bit detail, same concepts, same sections, but more in detail, right? So let us start with cell, the unit of life, right? So, the study of living organisms, their cell, structure, function, physiology, evolution, and everything about cell will be discussed in this chapter, right? In biology, we will be talking about the living organisms, right? How do we define biology? Study of living organisms. So as in the 11th class, you will be talking more detail in biology. So biology is what? Study of living organisms. So we can mention it here before diving into the chapter. Study of living organisms. Okay? And what are the living organisms made up of? They are comprised of cells, right? So study of the cells and its structure is called as what? Cytology. So let us define one more term. What is that? Cytology, that is study of cell and its structure, right? That we will be doing in this chapter. Now, before going into the chapter and its topics, I would like to introduce you about the cell history and its background, like who has given the term cell, who has discovered the cell first time, who has discovered the first living cell, and all that. Okay. So, the first person who has observed the cell for the first time and coined the term cell was Robert Brown. Who was that? Robert Brown has discovered the nucleus. We guys are already familiar. Robert Brown has discovered the nucleus, and Robert Hooke is the person who is known to discover cell for the first time in cork cell, which is a dead cell. He has observed a thin slice under microscope. Okay, so Robert Hooke in 1665 observed the first cell and also coined the term cell in his book. Although the book is not mentioned in your NCERT, but I would like to tell you for information, the name of the book is Micrographia, right? What is the name of the cell of Robert Hooke? That is Micrographia. There he mentioned about the cell, right? But it was a dead cell because it was a part of bark of tree, which is a dead part of the tree. So who has discovered the first living cell? The first living cell was observed by a person who was a lens maker by profession. And what was the name? You guys have already studied in 9th standard. That is Anton von Leeuwenhoek. So, Anton von Leeuwenhoek was the first who observed the first living cell, right? He was the first to observe living cell. He studied several bacterial cell, algae, and etc. Right? Now, at present day, we can say that all the living beings, be it plants, animals, microscopic forms, every living organism is made up of cells, right? But imagine at that time when microscope was the recent discovery. None of the advancement of science has been discovered at that time. So how was the situation at that time? How can we say at that time that all living organisms are made up of cells? So my dear students, the first person or the people who proposed the cell theory and stated all living organisms are made up of cell and its product was given by two scientists. What was that? Who were they? So we call the theory as cell theory given by the German botanist. What was the name? German botanist, the name was Schleiden, and British zoologist. What was the name of the British zoologist? Schwann. British zoologist, and the name of the zoologist is Schwann, right? They have together formulated the cell theory, right? I'll write it again. Zoologist Schwann, right? They have together formulated the cell theory. German botanist Schleiden and British zoologist, that is Schwann. Now this British term is replaced by German for zoologist also, and it is a latest update. It will not be mentioned in your NCERT. In NCERT they would have given the German botanist Schleiden, the British zoologist Schwann, but note it here, now it is German zoologist also. Is that clear? Yes. What they have given the statement? They have given the statement that all living beings, be it plant or animal, are made up of cells and its product only, right? So what was the statement given during cell theory? All the living beings, be it plants and animals, they are made up of cells and their product. I hope you all are writing this in your notes as well. Okay? Yes. Now, there is a certain limitation of this cell theory. And what is that? Yes, I'll tell you the limitation. The limitation is that they are not able to tell from where the new cells are arising. That is fine that they predicted that cell theory states that all living beings are made up of plants and animals and its product, but they were not able to tell from where the new cells are arising. So the cell theory was reformulated in 1855 by another scientist, and the name of the scientist is Rudolf Virchow. Rudolf Virchow, who has reformulated the cell theory. Reformulated the cell theory. In the Latin language, he has given a statement which is also mentioned in your NCERT, and that is omnis cellulae e cellula. What is the statement? Omnis cellulae e cellula, which is a Latin language, which means cells arise from the pre-existing cells only. What does it mean? They stated, this statement means that cells arise from pre-existing cells by division. This was the meaning. We added by division process, the new cells are formed. And what was the time of discovery? It was reformulated in 1855. Is that clear? So you can go through it once again. So what was the year of the cell theory? It was 1839 and 38, together by German botanist and zoologist, whereas it was reformulated in 1855, right? Yes. All right. Now let us proceed further. Rudolf Virchow has reformulated the cell theory as omnicellulae e cellulae, which is a Latin language, which means cells arise from pre-existing cells by division. Now let us give the conclusion for the cell theory in two final statements. Number one, all living beings are made up of cells and its product, be it plant and animals. Whereas the final second statement is that cells arise from pre-existing cells and they are formed by the process of division. We can see here, if this is a parent cell, then it divides to form two daughter cells. Then further it divides to form more daughter cells, and the process continues like that in order to form new cells. Did you got my point? So this is all which was given by German botanist, British zoologist, and it was reformulated by Rudolf Virchow as the cells arise from the pre-existing cells only. Is that clear? All right. So now let us move into the types and variety of cells that is found in the nature in all the living organisms. So my dear students, we know that cells vary in its structure, in its size and structure, depending on their function. Depending on its function. It is very obvious, my dear student, that the profession, the work or the job that we do, we get dressed up accordingly, right? If a doctor is there, then he will wear a doctor dress, like the dress according to his profession. If a teacher is there, he will dress like this as my profession. If a chef is there, he or she will get dressed according to his profession, right? Likewise, the cells also vary in their appearance depending on the function they perform, right? So there are certain diagrams, there are several diagrams shown in your NCERT showing their structure as per their function. So I'll also be drawing those diagrams over here. You can see we have a nerve cell. We have a nerve cell with its branched network because it has to carry message from one part of the body to another part of body with its interconnected ends, right? So it has branched network. Are you getting my point? So this is the nerve cell, or simply neuron, which is the longest cell known, right? Yes. Another is, you can say, some secretory cells found in our body meant for secretion, called as columnar cells, right? So columnar cells are meant for secreting some fluids and mucus in the digestive tract. We will be discussing more about it in our upcoming lectures, but here we are talking about its appearance. Next, we can take an example of RBCs. Like RBCs are amoeboid in shape. Why so? Because they have to pass through the blood vessels. So they should be flexible in terms of their shape. If they won't be flexible, they won't be easily able to pass through the blood vessels. Are you getting my point? So as function, likewise their structure. Is that clear? Yeah. So the amoeboid structure of the RBCs. Is that clear? Yeah. Okay. One more example we can take over here, that is the structure of trachea, or the sieve tubes or the vessels present in the plant body where they are meant for conduction. So how do they look like? They look like this. I can draw it over here. Depending on their function, they also have a tubular structure or pipeline like structure, so that they can transport water along with it, right? So that is why I have written cells vary in its size, structure, depending on its function. Is that clear? Now I would like to tell you about the smallest cell known on this living system. And what is that? Should I move on the next page? Yes. You can note it down. This is your trachea. This is your trachea. Now moving ahead, as I told you, the smallest cell known is of mycoplasma. What is that? Mycoplasma. The smallest known cell of 0.3 micrometer in size. What is micrometer? 10 raised to power minus 6. So mycoplasma are of 0.3 micrometers. Then your RBCs are of 7.0 micrometers in diameter, right? These are the two sizes that you need to recall because these are mentioned in your NCERT. While rest of the cells, even you are not aware of the size, that is also fine. So I would like to give some examples of their sizes, such as the largest cell is egg of an ostrich, right? The longest cell we already discussed, that is the nerve cell, okay? And the smallest cell we are already told it is around 0.3 micrometers, whereas what is the size of bacteria? They ranges from 3 micrometers to 5 micrometers in size. So that's all about the range. You can see how greatly they vary in terms of their size and the structure depending on their function. Is that clear? Yeah. Okay. Now we will see the basic structure of a cell depending on what function, what activities they are doing. We will see what are the constituents or the composition of a cell. See, broadly, a cell consists of a liquid arena surrounded by a membrane called as cell membrane. And the liquid arena where all the activities are performed. The liquid arena where all the metabolic activities are performed inside the cell is called as cytoplasm, whereas the surrounding membrane is called as cell membrane. Right? This is the arena of the cell, which is the site to perform all the metabolic activities, right? And what do we call that? We call them as cytoplasm. That is found in all the cell irrespective of its type. And what is the second structure? The second structure is cell membrane, that is the boundary of the cell. Now, we will see some of the cell have certain membrane bound structure. We will see some of the cell have certain membrane bound structure such as ER, Golgi bodies. We will see sometimes nucleus, some other structures that we will be drawing in detail, right? So sometimes some membrane bound structure are also present called as organelle. What are cell organelle? Membrane bound structure found inside the cell. For example, mitochondria, right? For example, ER, for example, Golgi bodies, etc., that we will be discussing one by one in detail. These are not the only organelle, there are many more, but the next topic is we are going to talk about the two types of cells, that is prokaryotic and eukaryotic. Then in eukaryotic sections, we will be talking about this organelle in detail. So I hope I'm clear with the concept about the basic structure. The cytoplasm, that is the liquid part, main arena of the cell, which is site to perform all the metabolic activities. Second is the boundary, cell membrane. Third is the cell organelle, which are the membrane bound structure found inside the cell, such as mitochondria, ER, Golgi bodies, and etc. Is that clear? Now I'll be moving towards the two basic type of cell. One is the prokaryotic, another is eukaryotic. So let us put the new heading for that. Right? Okay. So let us start with the prokaryotic type of cell. Broadly, dear students, we have two types of cell. One is the prokaryotic, another is the eukaryotic. So before talking about a particular type of cell, let us understand the difference between a prokaryotic and a eukaryotic cell, right? So we have two types of cells. Number one is your prokaryotes, and another is the eukaryotes. Now, we have already discussed about these two terms in our previous classes, not exactly by me, but there would be definitely some other science teacher or biology teacher who would have told you about these two terms, the prokaryotes and the eukaryotes, right? So here, karyo term is common in both the type of cells. So what do we understand by karyo? Karyo means nucleus, right? What does this karyo means? Nucleus, right? U means true. So the cell with the true nucleus, or the cell with the true type of nucleus, is called as eukaryotes, and the cell which have a primitive nucleus. Now what is that primitive nucleus? How it look like? That all we are going to discuss right now only. Pro means primitive here and karyo means nucleus. So one with primitive nucleus is called as prokaryotes, right? And the one with the true nucleus will be called as eukaryotes. Okay. Now let us see how the nucleus look like. See, if this is a cell, and the genetic material of the cell, such as the DNA, RNA or RNA is the blue chip, or the chip of the cell, which is carrying all the information about the cell, its division, time of division, how many division, how much growth, what metabolic activities. Every information is stored in the form of its genetic material. So that genetic material is very much crucial and the celebrity molecule for the cell. So cell will provide multiple level security to the nucleus. The genetic material is the celebrity of the cell, so it will provide multiple level security around the genetic material. So that type of nucleus where a multiple level security means multiple layered surrounding covering is there, that type of nucleus is said to be as the true nucleus, which is found in case of your eukaryotes. So let us first see the nucleus of the eukaryotes. If this is the genetic material of the eukaryotes, then this is the covering, around the true nucleus found in case of eukaryotes. Whereas if you see the nucleus of the prokaryotes, it is just scattered in the cytoplasm like this. Is that clear? So the prokaryotic genetic material is scattered in the nucleus like this, whereas the eukaryotic genetic material is present in the well-surrounded, multi-layered security. And when the nucleus is surrounded by a membrane, then such nucleus is called as true nucleus, that is eukaryotic cell, and the one which is having no membrane around its genetic material, then such cells are called as prokaryotes, which do not have a true nucleus. So please write down cells which lack true membrane around nucleus are called as prokaryotes, whereas the one which possess true membrane around nucleus is called as eukaryotes. That clear? Yeah. And in prokaryotes, where the nuclear membrane is not properly present, such nucleus are called as incipient nucleus. Very, very important. Very, very important, as it has been asked so many times in your NEET examination, incipient, not incipient. Yeah, incipient. Incipient nucleus. There is one more name, that is nucleoid, right? Nucleoid, incipient nucleus, all are the terms for the nucleus of prokaryotes, where here we simply called it is true nucleus because it is membrane bound nucleus. Is that clear? So please mark it as very, very important. Nucleoid and incipient nucleus. Is that clear? Yeah. So moving ahead, please note it down carefully in your notes, because you are going to face such questions in your practice paper or in your examination. So be aware about all the points. Whatever I am writing from the board, each and every point is very, very important for your examination point of view. Right? Moving ahead. Although there are several other points also which is different in prokaryotes and eukaryotes, such as the size. Prokaryotes are basically smaller in size, eukaryotes are bigger in size. Prokaryotes will not have well membrane nucleus, whereas this will have well membrane bound nucleus. Then there is one more point that you can mention here, that is, please write down. In prokaryotes, they lack membrane bound organelle also. You know, it's not only about the nucleus, rather prokaryotes also lack the membrane bound organelle such as endoplasmic reticulum, the Golgi bodies, the mitochondria, the lysosomes, etc. So it's not only about the well membrane bound nucleus, rather none of the membrane bound organelle is present in case of your prokaryotes. Okay? None of the. This I am writing about prokaryotes. Second point. And in eukaryotes, we will see that they have or they possess membrane bound organelle, such as all that we mentioned in this side, they are present over here, such as Golgi, mitochondria, lysosomes, etc. Is that clear? Yeah, that's all about. Now, we will be talking more about the prokaryotic system, and secondly, we will take the eukaryotes, right? So let us start with the prokaryotic system in detail here. I hope you all have noted this. Okay. So we are going to talk about prokaryotes in detail. So these are the star of today's lecture, prokaryotes. We are going to talk each and everything about the prokaryotes or prokaryotic system, or the organism which possess prokaryotic type of cells. So what are the organisms which do not have well membrane bound nucleus, and they are also simpler, more basic as compared to that of eukaryotes in every aspects, like in terms of size they are smaller, complexity they are small, they are less evolved, okay, their metabolic activities are very less evolved, everything they are, we cannot say inferior, but they are lower to that of eukaryotes. Okay, so what are the organisms which possess prokaryotic cells? So they are bacteria, then cyanobacteria, which are also called as blue-green algae. Then we just talked about the mycoplasma, the smallest organisms. So they are also prokaryotic. So let us write that also. Mycoplasma. What else? Bacteria, cyanobacteria, blue-green algae, mycoplasma. Yeah, that all are the organisms which possess prokaryotic type of cells, right? Then we will see this prokaryotic cells mainly consist of the organisms which belongs to which kingdom? Prokaryote accommodates the members of accommodates the member of kingdom. We will study in our upcoming lecture. There is a kingdom called as Monera. So it accommodates the members of kingdom Monera. Although those who are not aware of the kingdom Monera, we will be discussing later on, then you'll get to know. But as of now, you need to write they accommodates the kingdom Monera. Okay, so mainly prokaryotic cells are found in the bacteria, you can see. Okay, so what are the shapes, what are the types of bacteria that are found in the system? Let us discuss. The bacteria can be of different shape and size, different shapes basically, different shapes, and on the basis of shapes, they are named accordingly, such as number 1 is coccus. Coccus means spherical in shape like this. Are you getting my point? So they can be dispersed or they can form chain like this. If it forms chain, then we can call it as streptococcus, right? If they are found individually, we can call it as coccus, and the plural is cocci. So coccus, spherical. Number 2 is bacillus, that is rod shaped like this. Example is your lactobacillus. Okay. Then third is comma shaped, that is commonly called as vibrio, that look like this, comma shaped that look like this. Okay. And the third shape is the spiral. We call it as spirulum, that is spiral in shape. How does it look like? That look like this. Okay. So these are the type of shapes that bacteria show, which are type of prokaryotic cells. Yeah, because we are talking mainly about the prokaryotic system. So these are the general points or the salient features regarding prokaryotes that you can note it in your notes. Yes, is that clear? Okay. Now, more points regarding your prokaryotic system. Moving ahead. Number two is the cell envelope in case of the prokaryotic cell. Okay. See, the cell envelope in a prokaryotic cell is a three-layered structure. It's not single-layered or double-layered structure. Rather, the cell envelope in case of prokaryotic system is made up of how many layers? 3 layers, and we will see what are they, what is their sequence. Cell envelope in case of bacteria is 3-layered structure, and what are they? Let us draw it one by one. The outermost is said to be as the glycocalyx layer, right? Followed by the second layer as the non-living rigid structure that is said to be as the cell wall. Outermost is what? Cell wall. And the innermost layer in case of the prokaryotic cell is the plasma membrane. The plasma membrane. Okay, one by one we will look into the structure of the cell envelope of the prokaryotic cell. The outermost layer is glycocalyx. Let us write it outermost, glycocalyx. Followed by the middle one, cell wall. And the innermost is the plasma membrane. Now one by one we will talk about its function. Number one is glycocalyx. Glycocalyx, which is further of two types depending on its nature. Depending on its nature, one is the slime layer type and another is the capsule type. See, if this outermost layer, glycocalyx, is slimy in nature, it is sticky in nature, it has adhesive roles, it helps the bacteria to attach with the host and derive nutrition from there, or simply it is slimy in nature, mucus secreting, adhesive in nature, as the name suggests, slime layer, then such type of glycocalyx which is slimy in nature, role in adhesion, is simply called as slime layer. So we can write down. Point wise is slimy in touch, adhesive in nature, and helps to attach with host. Whereas the capsule is hard or tough covering, and it has role in protection. Is that clear? As the name suggests, slime layer capsule, it is tough, has role in protection. Or both are the type of outermost layer, that is glycocalyx. Please note it down. is this glycocalyx layer is made up of sugar and proteins. So it is called as glyco means sugar, whereas it is made up of proteins also. So we together call it as glycoproteins. Glycocalyx is made up of glycoproteins. So this was about the outermost layer. Moving towards the cell wall, that is the second layer. Shall I start with that? Yes? Okay. Cell wall. The second layer of bacterial structure envelope. Cell wall is the second layer of cell envelope, and it is made up of, if I write made up of like this, I hope you guys will understand, right? But currently I'm writing it like this, made up of peptidoglycans and lipopolysaccharides, which are the type of sugars and proteins only found in the cell wall of bacteria that you need to recall for the composition of cell wall, because my dear students, cell wall is made up of cellulose and pectin in plants. It is made up of chitin in fungi. It is made up of galactase and mannans. It is made up of galactans and mannans in algae. Likewise, the composition is different in case of bacteria. It is made up of peptidoglycans and lipopolysaccharides. You need not to write this as of now. We will be discussing in upcoming lectures. So, because it has different composition in different organism, that is why I am writing the composition of cell wall in case of bacteria. It is made up of peptidoglycans and lipopolysaccharides. Is that clear? Yeah? All right. Okay, so cell wall provides, what is the function of cell wall? Cell wall provide a definite shape to the cell, provide protection from the external injury or any of the type of mechanical injury. So it has role in protection and also prevents the cell from bursting. Okay? Yeah. So please note down the function. It provides definite shape to the cell. Protection also prevents the cell from bursting if there is any kind of pressure to the cell. Is that clear? Yeah. In case of glycocalyx, there is one more function, and that is, you can add it here, apart from this, glycocalyx, it prevent the cell from desiccation. What is desiccation? See, The glycocalyx is slimy in nature, sticky in nature, okay, has moisture in it. So it do not allow the cell to get dry. So we call it as prevents the cell from desiccation, right? What else it performs? Phagocytosis. What is phagocytosis? To trap and kill the harmful agents coming in contact with the bacteria, right? So two more functions, phagocytosis and prevent the cell from desiccation. Is that clear? Also, it provides virulence to the cell. What does it mean? What is virulence? If some of the bacteria or if any bacteria is causing some disease or it has some toxicity, so that is also imparted by its glycocalyx only. So my dear students, you can be asked several questions regarding these points, that which of the following is not the function of glycocalyx. So one more function that I am adding over here, and that is what? It provides virulence. Virulence to the cell. Virulence to the cells means if any disease or some infection is caused by certain bacteria, so that is also possessed by glycocalyx. So number 1 function, prevents cell from desiccation. Number 2, phagocytosis. Number 3, virulence to cells. And separately, they have separate function. Slime layer is slimy in touch, adhesive nature, helps to attach with the host. Whereas if it is capsule, it is hard in touch, role in protection. Is that clear? Yeah. Then next was our cell wall, provides definite shape, protection, also prevents the cell from bursting. Is that clear? Now the third layer in the cell envelope is cell membrane. So I hope you guys are already aware with the function of cell membrane. And what is that? It allows the passage of molecules between the atmosphere or the environment and the bacteria, or if there is any cell there. Is that clear? So cell membrane is made up of lipids and proteins. And what does it do? Has role in passage of molecules entering and leaving the cell. Is that clear? So I hope you all are clear with the functions of all the 3 layers of the cell envelope in case of bacteria. Yeah. Okay, please note it down. Then we will proceed further with the extension of the cell membrane, and that is a very important part in the cell unit of life. Let us move towards that. Please note it down. All right. So next is the extension of cell membrane. Very, very important structure in case of prokaryotic cell. You can highlight it in your notes as well. Mesosomes, because you are already aware that bacteria or the prokaryotic cell do not have any membrane bound organelle. So this mesosome is the structure which is going to perform all the function related to the metabolic activities of the bacteria, be it excretion, cell division, replication, enzymatic activity. You name a single activity in bacteria, that will be definitely performed by the mesosome. So what is mesosome? Please write down. What is mesosome? It is the enfoldings of plasma membrane, in bacteria only we are talking about, in bacteria which play role in, what are the functions? Which has role in replication, has role in cell division, has role in enzymatic activity and increased surface area for enzymatic activity, increase surface area, right? Then respiration. Is that clear? So all the function for the bacteria is actually performed by the mesosomes only. Okay? So this was all about today's topic. Till mesosomes we have completed about its function as well. So revise it properly twice, thrice, and then we'll meet tomorrow to continue the same topic with the prokaryotic cells. So that's all about today. Thank you. Have a good day.